So, very good morning and good afternoon from all of you viewers. And am I audible, team? Uh,
Yes, sir.
okay, let me extend my big thank you to the organization team, and I extend my warm welcome to all of participants and research and academic fellows who would like to share their new thoughts, creative work, and looking forward for next steps in their research goals. So. Uh, I'm very excited to see this conference and the part of this global conference meet. To be very frank, I work in different solo industries, and these are the opportunity like a global research teams where we all get the opportunity to participate and listen to the fellow researchers where they cross the platforms across the industries what different level of research are happening and get participate and apply in our industry and our academics. So uh, without wasting time and uh, uh, I look forward for every research to be very uh, a participant and active enough to know more and share their thoughts and share their insights. How do they fellow researchers experimented? What different level of observations they had, and what is their next goal to look at their research subject? So I would like to hand over to the chairperson so that we can get start on the uh, our plan activity to Mr. Norman Gumba. Would you like to start with your session activity, please?
Um, yeah, sure. Hello. Good morning for everyone. I hope everyone is doing well. Um, Welcome to the Global Research Meet 2026 International Conference on Multidisciplinary Research and Innovation. My name is Norman Gamboa. I am a Colombian attorney and IRS enrolled agent certified and financial risk management and tax compliance consultant. Um, it is both a pleasure and honor to serve as a session chair for this first technical session of the conference. On behalf of the conference and organizers, I would like to warmly welcome all presenters, keynote speakers, and researchers, professionals, and participants joining us from around the world. This conference brings together talented researchers and innovators to exchange knowledge, share ideas, and contribute to scientific and technological advancement across disciplines. Thank you all for being here today. Before we begin, I kindly ask everyone to keep their microphones muted during the presentations. And we will reserve comments and questions for the appropriate discussion periods. And we are going to start our session with our first um, presentation. It is a good time to start it?
Hi, Norman. This is Naga. I was planning for that at 5 a.m. My time, that is 11 a.m. So can we start at 11?
Okay, perfect.
Okay.
It's good. We have
Yeah,
20 minutes
that's great.
before time.
Okay, thank you.
Okay.
If I'm able to just start like in next minutes, I'll just definitely let you know and then we can start.
Okay, perfect.
So shall we start the presentation? So I invite the presenter.
Yeah, sure. I think we can start. The presenter is ready with.
So Naga is presenting in the 10 minutes uh, to present their paper.
We can start with the next person, or we are waiting for Mr. Naga.
Paper ID 1442. Mr. Anand Bandhu Chatterjee, are you present? Paper ID 112. Mr. Anand Bandhu Chatterjee, are you present?
It's little early for both of them. We are waiting for them. They will join.
Hello, everyone. Good morning. Sorry for keep you waiting. If you are up for it, we can start now.
Yeah, Shri Ram. Present your screen and we'll continue the presentation. Continue
Absolutely.
the presentation.
Thank you.
Okay, we are going to start with our first presentation. Is from Mr. Naga Venkata Shimran Choricetti. His paper is about hybrid indexing for operationally aware inventory costing. Mr. Naga, thank you for joining us. You may begin your presentation.
Right. Thank you. Is my screen visible?
Yes, sir.
Okay. Screen. Thank you. All right. So, good morning. Welcome, everyone, and thanks for giving me the opportunity. My name is Sriram Chodisetti. I've been in ERP space for around 20 years now, and today I'm going to present this paper which states like hybrid indexing for operationally aware inventory costing. We have simulation and ARP-based validation. So, going into that, so I just want to explain like how the real world inventory systems or supply chain operations, the we can see that the variability or volatility has been the normal, right? But most of the ERP systems and costing systems are kind of rigid in that aspect, and they go with the static costing elements and rules pre-decided before getting into the financial period, right? So this paper basically tries to bridge the gap where the operational reality is ingested into the costing systems. So just abstract the outline of how the dynamic systems, dynamic supply chains are currently functioning, right? And how the operational cost should actually influence and be attributed towards cost calculations, right? So uh, our paper basically merges an database technology, which is like hybrid indexing, where the keys or the values are, um, let's say, they are attributed to a different index based on their popularity, usage, and weightage or priority, right? So anyone coming from database systems, they would know, right? Like we have bitmap, hash map, or range, B tree kind of indexes, right? So I'm trying to repurpose that kind of terminology or technology to inventory costing, where I'm representing those different indexes as tiers for costing. So when we ran the simulations and everything, I could see that the tier stability for all the items that fall in different tiers after the algo is applied is around 90%, and even that happens under different volatile conditions, right? So basically, we are trying to bring in the operational reality, ingesting into costing systems without losing any financial integrity or auditability for each decision going forward. So here I'm just explaining how current ERP systems play a crucial role in costing of the inventory for reporting financial end of the financial period, and the traditional methods, and even like I would say like an ABC costing methods, right? Where the cost allocation is the key, like what different cost elements, how much it costing, resources, overheads, and how are we properly allocating, right? So there it ends. And those are again like framed at the start of the period or start of the year or end of the quarter. Think of like an inventory controller who's sitting at the junction of a period and thinking, okay, what is my history and how do my project my say, inventory operations for the next upcoming quarter, and how can I change my cost elements, right? This is again based on previous and projecting into future. You're making a decision at that point of time, which may remain true or may not for the through the entire period of the quarter or the year, right? And here I'm just saying that again, like dynamic inventory costing, whatever we are suggesting here, it uses hybrid indexing approach and assigns the cost tiers for each item based on the operational signals. And this is a past literature or a recent work actually, which is kind of in line with this inventory costing. And each of them talk about uh, uh, how to capture cost right? How to maintain the cost records of each activity within a construction management system, where the first paper says that, and how allocation can be done, or how to optimize the efficiency of supply chains, or basically how to optimize the cost and result, right? But most of these end at this optimization and everything, or kind of an analytics mode, but cannot actually plug in that analysis into ERP systems, because for ERP systems, auditability is very important. And for each financial decision made, what is the exact reason that ties to that? Because it's all debits and credits has to be balanced. So this paper, that's where it extends that functionality. And I just want to show what is the methodology we have used and everything. To start with, it's operational signal ingestion, right? What I'm talking about operation reality. What is operation signals is basically velocity, means the heavy influx of items, or movements of items, or sales of items, right? SLA sensitive items, handling effort. Like let's think about any machine, any specific item, machinery that needs special packaging, right? And travel time. When I say travel time, not just outside, but within your system, within the warehouse, how much travel time it takes for a put away transaction, or to pick it up, or to load into a dock, right? These are all the travel times, right? So, and demand volatility. So, how much of a demand has changed over the last few days for this specific SKU or anything. So, I'm ingesting all the signals from different systems into some stage tables or seed tables that can be again used in the next step, that is cost to serve model. And in this cost to serve model, what I kind of do is I try to normalize all the signals to within a day for a score between 0 and 1, right? Each signal, whether it's velocity, SLA, handling effort, travel time, everything gets normalized between a score of 0 to 1. And then here comes the cost controller or inventory controller inputs of how much of a weight you assign to each of those parameters or each of the score calculations, right? Because it's again industry driven. And based on the industry, they can choose which one to give higher weightage or lower weightage. So then I come up with a calculated combined score. On top of it, what I have given the facility is to prioritize the SKUs, in the sense few categories needs to be prioritized more based on your system or based on your business, right? So you can add an additional prioritized weight to the final calculation. And then comes the decision point, right? Once this calculation, the score is coming, is calculated, then it takes a weighted decision saying, hey, is my volatility now reduced, or is it still high, right? And is it stable enough, and is there no noise beyond for the past few days? And these number of days can be calibrated based on your inventory calendar and everything, how you maintain. So based on that decision, actually I check the volatility stability and number of days in buffer, and then promote that score to actual costing system. And that's where it tries to assign a specific tier to each item. And what it means, basically, the specific tier gives you a multiplier, and each multiplier again matched up with the score, the cost to serve score we already calculated, and then brings the final burden multiplier that can be applied to the costing elements related to overhead or resource or indirect costs. So that's where the entire framework comes in, starting with data ingestion layer, cost to serve ratio score, hysteresis, and then checking the buffer, waiting for the noise to be suppressed, checking the conversions, as in like, is it too much oscillating between the tiers, which is not needed, which is not required, checks the history, and then promotes or demotes the item to the respective tier. So that's the entire framework, how it works. I would just like to show some results of what happened when we ran it from actually 1,500,000 to 100,000. So we are ran this simulation across these many items for a calendar period of 1 week to 30 days. So I'm sorry, the first one, right? It shows that how the SKU count has changed between these tiers, and over a period of time, between after 4 days, how it stabilized, kind of, right? Most of the items fitting into T2, and T1 for the premium items, and T3 for less touched or low volume items, basically. So that's figure two. And the next figure, I want to explain the margin impact of adaptive costing. So we have seen good margin raise in each of these tiers, right? And we did screw our parameters, in the sense, for few scenarios we ran it with velocity high, or like a carrier disruption, or like applying a promo surge, right? Even in spite of these different skewed weights, the kind of consistency we achieved is more similar, wherein the new algo actually wins. And this is the convergence and the stability of the tier. And a sample of unit cost adjustments, what happened across the tiers, and how much of a margin lift happened, because this is where actually CFOs like it happen across all the tiers. And obviously T2 would be the heaviest, or I would say more skews would be attributed towards T2, where you see a heavy margin, but on T1 you would see good price adjustment. So you're actually calculating the cost of an item and directly tying its operational reality to make sure that we're costing at the right price. So this is further again, what is the margin lifts happen in different scenarios. And I'm just showing what is the difference between ERP native systems and where the hybrid indexing actually comes into handy. So I would like to just summarize how this is different. ABC costing, we have a really stable thing, and we could have gone with RL or ML models where it digs in history, recognizes patterns, predicts future. But for when you are actually accounting and inventory costing, ERP systems, they try to they want auditability, and I can like the drill down to detail of why this change of a cent has been debited or credited on based on which activity, right? So the ingestion of the all the data and maintaining the auditable fields, like, okay, when did I promote, what was the volatility reached, what is the new score calculated based on what parameters, and who approved it. So all these kind of audit fields help us to directly use it against an existing ERP system. So the future work would be like fully automating how with the different ERP systems on ingesting, or actually modifying the multipliers for the cost assigned to cost elements, and some integrations with different ERPs. That's the future I'm thinking on how to expand this. But thank you so much for giving me the opportunity, and I would take any questions if anyone has, or any inputs actually.
Thank you, Shri Ramji, for your insightful presentation. We will now open the floor for question and discussion. If anyone has a question for the presenter, feel free to ask.
So, so Nag, I think this was a great insights of the ERP system. A quick reflection towards so how you there are point I think you nicely covered about the auditable and compliance. So do you quickly uh, can you share a quick insights of this? Like there are, let's say, some few compliance specific items which may extend the delivery or prioritize the delivery. So are they considered it in this simulation, or let's say there are some X-ray items and the nuclear items which are part of the shipments and participant in the ERP. So, so is there any effect or such, or uh, has it been covered like special cases? Would you please guide?
Absolutely. Absolutely. So think of like COVID times, right? Where like we had like a lot of medical related equipments which are being transferred, right? So that's where we know that your in within your ingestion, data ingestion, the SLA sensitivity or the equipment handling, right? Special handling factor becomes really important here, right? And if you are into that industry, I know I worked for one of the industry called Igloo. So they were manufacturing special coolers for this very example, right? So now they know that these specific item categories have to be weighted additionally, right? The weightage of those kind of categories should be more during this season, right? So that's where the controller has flexibility to calibrate the parameters. And now that's specific to industry, right? So definitely it will, since of the extra weightage, it will show that burden multiplier more for that kind of items, right? And now comes to auditability, right? The calibration of parameters is approved and audited. Like you have all the, in ERP systems we call who columns, created by creation date, modified by modified date, right? So those maintain who made this decision. And during the entire run, right, of simulations, not just simulations, when are actually it's running in parallel and end of the month it's giving you the input, right? It shows why it had to change the multiplier in the sense between the reason between T2, T1, T3, right? And then again it puts in buffer to suppress the noise, right? You're not just accepting everything as is, you're putting in a buffer to make sure the demand volatility has remained stable for an X number of days. And then you're actually promoting. So there is two promotion criterias. I did not get into detail. One is length of stay in buffer and the volatility, constant volatility. And the other thing is period end, where you are forced to promote a suggestion or ignore that suggestion because you have to end of the day cost your inventory for that financial period. So all these attributes what I've mentioned become the auditable fields for promotion or demotion, and basically ties to why that calculation has come up with.
Thanks, Naga. Clear.
Oh, oh,
Thank you.
okay.
Thank you. Right. Any further
Thank you.
questions?
Thank you for your excellent presentation and for sharing your valuable research with us.
Thank
We
you.
appreciate your contribution and the insights you have provided.
Thank you so much.
Thank you, Mr. Naga, for your insightful presentation.
Thanks so much.
Okay, we can move forward with our next presentation.
Okay, I would like to invite our next presenter, Mr. Anant Bandhu Chatterjee. The paper ID is 1442, and the title is Cloud and Edge-Based Distribution Computing: A Survey of Architectures and Resource Management Approaches. Mr. Anant Bandhu Chatterjee, are you present? Paper ID 1442. Mr. Norman, please invite the next paper ID.
Mm, Okay, Mr. Anadis is ready, or we can move forward with the next presentation.
We can move forward with the next presentation.
Okay, our third presentation is Mr. Akhil Reddy Dugasani. His paper is about a large language model framework for early software bug prediction. Mr. Dugasini, are you ready?
Yep. Hi everyone. Good afternoon. Good morning. I'll share my presentation right now. Just a second.
Okay, perfect.
Can you see my screen?
Yes, sir. We do.
Okay. Yep.
Yes, we can.
Good afternoon, everyone. My name is Akhil, and today I'll be presenting my work title, A Large Language Model Framework for Early Software Bug Detection in Software Engineering. The main idea of this work is to predict software bugs early using machine learning and transformer-based models. Early prediction helps developers identify risk modules before they become even serious problems. Just a second. Yep. In this presentation, I'll be covering I'll explain the abstract and introduction, and then I'll discuss the literature review and methodology. After that, I'll present the results and discussion. And finally, I'll conclude with the future scope and references. So software defects can affect the reliability, performance, security, and quality of software systems. As software systems become more complex, manual bug detection becomes more difficult, time-consuming, and error-prone. So early bug prediction helps development teams to identify defect-prone modules in advance. This allows them to prioritize testing and maintenance more effectively. Traditional approaches used static code metrics such as coupling, lines of code, and cyclomatic complexity for this. In the recent years, machine learning models such as neural networks or decision trees or SVM, random forest, have shown better performance in identifying these patterns. The main aim of this study is to improve early software defect detection using machine learning and deep learning techniques. So the study focuses on early software defect detection using two main models. One is random forest and the other one is Distilbert. Um, the dataset was processed using several steps such as data pre-processing, feature engineering, smart balancing, and robust scalar normalization. These these models were evaluated using accuracy, precision, recall, F1 score, ROC, AUC, and training time. So Random Forest achieved the best performance with 99.98% accuracy, while Distilbert also performed strongly with 99.39% accuracy. At last, sharp explainability was also used to identify the most important features that influence the defect prediction. This helps make the model more transparent and easier to understand. As we can see here, I'll discuss some previous research in the software bug detection. So different researchers have used models such as CAN, double stacking ensemble models, BISP, random forest, or NLP-based ensemble models and graph-based models for prediction techniques. These studies showed good improvements in defect detection, but they also have some limitations. Some models were tested on small data sets, some had high computational complexity, some lacked explainability, others were not validated in real-time software development environments. So the research gap is that we need a defect prediction model that is more accurate, scalable, efficient, and interpretable. So I'll discuss the methodology followed in this system. First, the software defect prediction dataset is collected from Kaggle. Next, the pre-processing is performed to check for missing values, duplicate records, and inconsistencies. Then exploratory data analysis was applied to understand class distribution, feature patterns, and imbalance in the dataset. After that, feature engineering is applied to create new meaningful features. Then the dataset is split into training, validation, and testing sets. At last, robust scalar is used for feature scaling, and smart is used for class imbalance. Finally, random forest and Distilbert models were used for training, and the results were evaluated. Sharp analysis was used to explain the predictions on why a specific feature was important in defect prediction. So coming to the results, random forest achieved 99.98% accuracy, 99.76% precision, 99.99% recall, while Distilbert also achieved 99.39% accuracy, 99.66% precision, and 99.71 recall. But random forest required less training time, around 110.87 seconds, while Distilbert required little bit more time, which is 133.80 seconds. From these results, we can say that random forest performed better overall, with a slight less, I mean, with a slight less performance in Distilbert, especially for this structured software metrics dataset. Coming to the ROC curve, it shows how well the models distinguish between defective and non-defective modules. Random forest achieved a AUC value of 1, and Distilbert also achieved a similar value of 0.99. Since both values are very close to 1, both models have very strong classification ability. The Distilbert training and validation graph shows that the model learned effectively. The loss decreased and accuracy increased during training. The validation accuracy was also so high, which means the model generalized very well and did not show any major overfitting. At last, SHARP analysis was done. SHARP was used to understand which features contributed most to the model prediction. The top 5 important features were past defects, static analysis warnings, cyclomatic complexity, test coverage, and risk index. This means that modules with more previous defects, more static analysis warnings, and low test coverage are more likely to contain bugs or defects. The sharp dependence plots also show that as static analysis warnings and cyclomatic complexity increase, the defect prediction risk also increases. This makes the model more explainable and also useful for the developers for early detection of the defects. As we can see here, the proposed models were compared with the existing baseline models such as ANN, CNN, decision tree, Adaboost, and SVM. The baseline models achieved accuracies ranging between 76 and 83%, while random forest achieved 99.98%, which is very high, and also even the Distilbert achieved similar accuracy, which is 99.39% accuracy. So even the F1 scores for these proposed models were comparatively very significantly higher, and this shows that the proposed framework performed very better than the existing baseline models or methods. The improvement is mainly due to the proper pre-processing, feature engineering, class balancing using SMART, and also effective model selection. In conclusion, defect detection is important for improving software quality, reliability, and maintainability. This study proposed a framework using random forest or Distilbert for early software bug detection. Random forest achieved the best performance, while Distilbert has also shown similar percent of accuracy. But random forest was more computationally efficient compared to the Distilbert because of the structured data set, while the Distilbert is more efficient with the text-based data sets. Sharp analysis helped to identify the most influential features affecting defect prediction, such as past defects, cyclomatic complexity, test coverage, etc. For future work, this framework can be tested on a larger and more diverse real-world software projects. It can also be integrated into CI/CD pipelines for real-time defect detection. Advanced code-aware transformer models such as like CodeBERT, Craft CodeBERT, or any recently introduced large language models can also be explored here. Another future direction is to combine source code, commit history, issue reports, developer activity, and code review comments as some of the new features to improve the prediction accuracy. Finally, the system can be deployed as a dashboard to help the software systems or software teams to prioritize testing and maintenance and identify the issues early before even the production deployment. With this, I would like to conclude my presentation. Thank you for your time and attention. Please let me know if you have any questions on this one.
Okay, thank you, Mr. Dugasani, for your excellent presentation.
Thank you. I'll stop the screen share.
So one quick question, Akhil.
Mhm.
If, would these packages is available for compiler collections currently available, or any study around that has been uh, posed?
Can you repeat that question? I didn't get it clearly.
So this early detections towards the maybe a speculation of a defect or
Mhm.
improvement. So would these packages or participant into the compiler corrections? Means let's say GCC or any open source compiler collections are also
Not not really.
exploring this.
No, as of now, this was not included. Like, I mean, GCC and compiler level detection at the compiler level detection, but we can use it in CI/CD pipelines where before even the build, I mean, we generate the artifact, we can use that build pipeline during the pipeline, um, like similar to the Qualys or SonarQube. We can use this as another step to identify the defects.
Okay.
Hope this makes sense.
Okay. Mm. Thanks, Akhil. Thank you.
Thank you.
From where you take your data set?
It's from Kaggle.
Uh, can you tell me about something about your data set?
Okay, so the data set is it has like 60,000 uh, rows with 23 features. Basically, it has higher non-defective uh, rows. I mean, non-defective entries compared to the defective entries. Like 97% of the entries were non-defective, and the remaining 3% was defective ones. I applied some smart analysis to balance the uh, class imbalancing, because otherwise it could lead to overfitting based on one type of basically non-defective class. That's why smart analysis was also used.
Okay. Can you tell me about something about the smooth analysis, or what is the uh, basic working of smooth? Why we use this?
So smart analysis is used basically to um like what we say to reduce the class imbalance. So in case of the data set is queued towards a specific what do you say to a specific class, or like to a specific class, then the results might not be as accurate as possible. So in order to reduce that, we need to apply some balancing, which is nothing but synthetic minority class oversampling technique, which will take the minority class and try to generate some synthetic samples out of those, and it will create some synthetic data entries to balance the classes, like here in this case defective versus non-defective classes.
Okay. Sounds good. The last question is, why
Mhm.
the your research is better than the previous researches?
So basically here the models which we used, like one is Distilbert and the other one is random forest. And these have, especially the random forest is uh, mainly very, I mean, it works very well with the structured data set. And even the Distilbert, which is a transformer based model, which is which is part of a family of language models. These provide better computational. I mean, these have an efficient computational time, and also what do you say? When we compared it with CNN or ANN or SVMs, these showed better results.
Okay. Uh, Mr. Norman, you have any question?
No, I haven't a question. Thank you.
Thank you.
Okay. Thank you for the your presentation, valuable time and valuable research.
Thank you.
Okay. Thank you, Mr. Dugasani. Um, According with our schedule, we can move forward with our keynote lecture. Is Mr. Vika Somani ready?
Uh, Mr. Norman, I think he is not available right now. Shall we go the next paper? The paper of Mr. Aniket Naresh Bajaj. The paper ID is 1452.
Okay, we can move forward with the presentation number 4.
Yeah.
Okay, we are going to continue our technical presentations. Our next presenter is Mr. Aniket Naresh Bashab. His paper is about survey of AI driving techniques for enhancing clinical decision making.
Yes, sir. Let me share my screen.
Mr. Aniket, please turn on your camera.
Yes, sir. Wait a minute. Good morning, sir. Good morning, everyone.
Okay, start your presentation.
Yes. Mm, So, good morning, everyone. My presentation survey of AI-driven technique for enhancing clinical decision support in modern healthcare system. These work focused on how artificial intelligence and deep learning
Mr. Aniket? Maybe he lost connection. Maybe if Mr. Anik reconnect later, we can continue with Miss Abigail Chiwaka. Could you unmute your microphone, please?
A very good afternoon to you all, or is it morning wherever you are?
Yeah.
I will share my screen and my presentation. I'm struggling there. Just bear with me, please.
Yes.
Can you see my screen now?
No, no. We can see it.
Um, how about now?
No, not yet.
And now?
No.
Oh, hello there.
No.
Are we winning? I'm having technical issues here. Can I come back later on?
Yeah, sure. Maybe, I don't know if it is available, Dr. Abid Hussain, maybe?
Yellow?
Yes?
Yes, can you see my screen now?
No.
is in your meeting, there is one option, share a screen. You can share your screen.
Hello? Hello? Yes, I'm doing that, but please come again. Um, Yes, that's what I'm doing. I cannot share my screen, entire screen.
Yes, just click on entire screen. After that, select the screen and click on save.
That's what I'm doing. It's not working. I'm sharing my screen right now. Can you see it?
Yeah, yeah, Abigail, now your screen is visible.
Is it visible now?
Yeah, you can start your presentation.
Okay. Oh. Okay. We'll start now. Right. Are we together?
Yes.
Yeah, please continue.
Yeah, my topic, once again, good afternoon. My topic is a review on the role of innovative leadership in educational technology and student learning outcomes. This study investigates the relationship between innovative leadership and technology integration in educational settings and their combined effect on student learning. The method that I used was a quantitative survey-based research design. And the key finding was a strong positive correlation between leadership and technology adoption. The impact there was a measurable improvement in student engagement and performance. My introduction, digital technology is fundamentally reshaping how students learn and how educators teach. From Internet of Things enabled classrooms to AI-powered platforms and learning management systems. The tools are available, but leadership is the catalyst that drives meaningful adoption. Like I said, there is the Internet of Things that connect devices creating immersive learning environments. And we have AI, the adaptive platforms personalizing student experiences. We also have learning management systems. These are centralized systems streamlining instruction and assessment. And the biggest of all is leadership, which is the key variable for successful, sustained integration. The literature review, what is it that we know? Existing research presents a complex picture, like the one you see here. While technology's potential is widely acknowledged, outcomes vary significantly depending on context, implementation, quality, and human factors. Where is the critical gap? The critical gap is a few studies examine the combined impact of innovative leadership and technology integration on student outcomes. This study addresses that gap directly. Moving on to a methodology. An online survey distribution was used and a quantitative cross-sectional research design was employed to capture a snapshot of leadership practices, technology use, and student outcomes across diverse educational settings simultaneously. The participants were mainly students, teachers, and administrators across multiple institutions. An structured online questionnaire using a validated Likert scale was used, and the analysis was descriptive statistics and correlation analysis via SPSS. Still on methodology, data collection and analysis. Data was gathered through a structured online questionnaire that was distributed to participants across educational institutions, both in urban and rural settings. Responses were processed and analyzed through using the SPSS statistical software. Summarizing response distributions and demographic profiles, correlation analysis, measuring relationships between leadership technology as well as outcomes. And the key measures were leadership quality, technology use frequency, student engagement, and performance. We come to data processing. Rigorous data cleaning ensured that the integrity and reliability of all findings before analysis. The surveys with missing critical fields were excluded from the dataset. Duplicate entries and formatting inconsistencies were identified and removed. Statistical techniques applied to address gaps and anomalous data points. Categorical responses encoded for quantitative statistical analysis. And then the key findings were the results reveal a very strong and positive correlations across all measured variables, confirming the central hypothesis of the study. All participants reported high levels of both leadership quality and technology use, with measurable gains in student engagement and academic performance. And then in the conclusion and future directions, what did we confirm? We confirmed that innovative leadership directly improves technology adoption, which in turn enhances student engagement as well as academic performance. What is it that is needed? An expanded professional development, institutional support structures, as well as targeted training for educators at all levels. Recommendations for future research. Larger scale studies, longitudinal designs, and investigation of imaging technologies like generative AI in classrooms. There you'll see the references, and that is all I have for you this afternoon. Thank you very much for the opportunity. I will take any questions.
Thank you, Ms. Walker. I have a question. What leadership behavior are most effective in fostering innovation and improving organizational performance?
Please come again.
Yes, my question is, what leadership behavior are most effective in fostering innovation and improving organizational performance?
One last time, please come again.
Yes, I am asking about what kind of related to the leadership behavior it is more effective in fostering innovation and improving organizational performance.
Oh, okay. The leadership needs to be to have a vision and be focused, as well as being adaptable, so that they can adapt to any change and encourage learners and as well as staff and students to adapt to known technology. I hope that answers your question.
Yes, thank you so much.
Abigail, you have a second paper also, the paper ID, I think 1455.
Yes, I do have another one. I'll share that one now.
Yeah, you can present the second paper also.
Okay. My next paper is on examining the relationship between educational technology usage and academic excellence. The research overview, the context is regional technology transformed education which was accelerated by COVID-19, which encouraged remote learning. And the methodology used was mixed methods. 100 respondents were interviewed, and we used the 5-point Likert IBM SPSS analysis. The key finding was strong positive correlation between educational technology and academic excellence. Leadership is critical. The context and problem statement, the digital shift, learning management systems, virtual classrooms, and MOOCs now central to learning. Redefining excellence beyond test scores, critical thinking, collaboration, creativity, and what were the persistent barriers? Infrastructure gaps, teacher reluctance, because they are not well versed with technology, and unclear impact on outcomes. And moving on, the previous studies and the research gap on this particular issue was mainly EdTech and engagement, which boosts participation and skill development, according to Xiaomet 2024. Online learning slightly improved GPA to performance loss. And then leadership. Transformational leadership drives teacher and tech adoption. The design and data collection on the methodology. The research design. The research design was mixed method, descriptive and correlational. Variables, independent EdTech usage, dependent academic excellence, mediating, leadership support, and tech readiness. Samples were 100 respondents, which comprised of 31 students, 69 teachers, which was stratified and purposive sampling. Moving on to data preparation, demographics, and ethical compliance. There, we had a group of students and a group of teachers. The students comprised 90.3% within the age group of 15 to 17 years, and 61.3% of these students were from the urban areas. And when it comes to teachers, 34.8% aged between 35 and 44 years, and 75.4 of them came from the urban areas, the rest from the rural areas. There was a higher female representation across both groups. The participation was voluntary, and consent was informed, and anonymity was assured. Moving on to perceptions of EdTech and learning experience. The key insight is high consensus that EdTech enhances learning, but tech accessibility remains a challenge, especially in the rural schools. Statistical relationships. Three emerging EdTech dimensions. There was the digital engagement, multimedia and interactive had the greatest effect on motivation. Adaptive instructional, AI personalized. I've lost that. Then I move on to conclusions and recommendations. Number one, we have to build infrastructure, equitable access to digital tools. There's also need to invest in training in order to prepare educators for new technologies, adopt blended learning, combined traditional and digital methods, foster digital culture, align tech innovation with institutional goals. And then you see my references, and I say thank you yet again for this opportunity. I'll take any questions.
Thank you, Ms. Abigail, for your presentation.
So I have a quick question, Vigani. It's regarding the how do you see the government participation? Because it's quite futuristic participation, and it's education. It's a backbone of a system. How do you see uh, uh, the participation of a government? How critical it is, or I mean,
This is okay. Yes, I will speak from the Zimbabwean perspective. There is a need for the government to come in and provide the necessary resources, especially in government schools. The funding right now is below par, and it is our sincere hope that the government will prioritize education and give a substantial budget for education in order for our learners to move with the times and get to use the new technology.
thank you.
Thanks very much.
Thank you, Ms. Chiwaka, for your insightful presentation.
Thanks for your time.
Mr. Norman, I think Mr. Aniket Naresh Bachav is ready for the presentation. The paper ID is 1452.
Okay, perfect.
Mr. Aniket, are you ready?
Yes, sir.
Okay, so present your screen and start the presentation.
I am myself Ankit Bachab. My presentation topic is a survey of technology for enhancing clinical decision support systems and deep learning, and can improve clinical decision support system for better healthcare prediction and diagnosis. So this is our table of content. So in this presentation, brief cover of research methodology, results, conclusion, and in the final reference. This is our abstract part. So, as we all know that clinical decision support system or CDSS helps doctor to make more legal decisions, but the are oftenly struggles with the large and complex healthcare data set. To solve this problem, AI techniques were integrated. In this work, NN and GR, the Mimic 4 healthcare dataset with processing technique such as sensing were applied to improve the data quality. The proposed hybrid RNN plus accuracy outperforming models like LSTM, AdaBoost, XGBoost. Let's move to the next slide. The healthcare industry generates a lot of patient data every day. So for the doctor and healthcare professional, it is there is a need of an based CDS have limitation when it comes to handling the complex medical data. Machine learning using EHRS, which is electronic health records. Therefore, the study proposed a hybrid RNN and GRE framework to improve the prediction performance and enhance clinical decision making. Let's move next slide. This is our literature review part. As we can see that this table summarizes previously research which is related to AI-based clinical decision support system. As we can see that different researchers use different type of algorithms such as XGBoost, random. As we achieved 97% accuracy using XGBoost model for heart disease prediction, and Jaya Singh case studies have achieved a good accuracy. Several challenges which are exist till now, like handling the heterogeneous type of the data, improving the reducing overfitting, achieving better generalization. These limitations motivate the development of the proposed. This is research methodology. This figure shows the proposed workflow of the system. Data for data set. The data is then and pattern distribution and correlation between the features. After that, the data is passed through the data pre-processing state. In removing outlier values, we normalize the data values. For balancing the classes like minor and majority classes, we use smooth. As we all know that there is generally an imbalance between in the medical data set. After balancing is done, the data is split into two parts, training part and testing part. The training part cover about 80% of data set and testing part cover about 20% of data set. After that, metrics such as accuracy, precision, recall, and urban score. This is our methodology in detail. As I said before, dataset collection from Kaggle, we perform EDA, distribution, process it. This is our result part showing the result which we achieved through it, and this is our accuracy. The plot shows that the accuracy is increasing for training and validation smoothly and slowly, gradually, converging that the training is done good with less error. After that, this is our loss curve for hybrid RNN plus GRE model. For RNN plus GRE model, as the plot shows that the loss is gradually decreased and nearly to the zero. This show strong training. This is our comparison table showing the comparison between our proposed model and already existed model. As our proposed model beat the already existing models, this is our conclusion. To conclude, we can say that AI-driven clinical decision support system can improve healthcare diagnosis and treatment planning. In this work, a hybrid RNN GRE framework was developed using the Mimic dataset. The data preprocessing and the balancing were performed. Proposed model outperformed traditional machine learning models with excellent evaluation results. But for the future, the model can be tested on multiple health center data sets. We can implement explainable AI to it, and real-time deployment can also be explored. This is our references. Thank you everyone for listening and for your attention. I would be happy to listen for the questions.
Thank you, Mr. Anike, for your presentation.
Mr. Norman, the keynote is ready. Mr. Vikas Somnani, can we proceed with this?
Yes, sir. We will now move our second keynote lecture. It is my privilege to introduce Dr. Abid Hussain. Dr.
No, sir.
Hussain.
Sir, Vikas Somnani. Vikas Somnani.
Oh, okay. Okay, perfect. Thank you. I would like to introduce Mr. Vikas Somani. Mr. Somani, thank you for being with us today.
Thank you so much, sir.
Yes, sir, please, could you proceed?
Yes, sir. Thank you so much, sir. So a very good afternoon to all of you, all the distinguished researchers, academicians, innovators, and industry experts. It is really a privilege to address the GRM 2026 on a topic that is transforming every branch of your engineering, including basically artificial intelligence and machine learning. So today is no longer a future technology. It is engineering present operating system. So basically, when we are talking about this, if possible, could I share my screen?
We can see it.
Yes. Just
Okay.
hope screen is visible.
Yes, sir. It is visible.
Thank you. Thank you so much, sir. So in today's era, we all know that basically AI and machine learning. So in my today's presentation, I'll just cover a few trends which are totally related to the engineering, from automation to intelligent engineering system. So basically, when we are talking about AI, so why AI matters in engineering? Because I'm basically from the engineering background. So we all know that basically when we are talking about the engineering, so something if we are know that a traditional engineering just focused on the design, efficiency, manufacturing, and optimization. So only these are the four key pillars on which a traditional engineering stay. But in case of modern engineering, now it will include a prediction, adoption, automation, self-learning system, human-machine collaboration. So when we are talking about a human and machine collaboration, something related to the AI, related to your, you can say that it's a machine learning, something, it will be involved here. So this is the era of your AI in engineering from 1950 to 1990. Rule-based systems are working 1990 to 2010. Statistical learning and a deep learning revolution will become from 2010 to 2020. Then from 2020 to 2024, we all work on a generative AI. Now 24 to 26, it's a multimodal AI plus AI agent. And now in future, we all know that it's a autonomous engineering intelligence. So we all are working on that basically. So these all are the core AI technology transforming your engineering. So all the researchers who present here the papers, they all are know that something in your paper you will use any of one of them technology, which is basically a core AI technology. Maybe someone use the machine learning, maybe someone use the NLP, maybe someone use the generative AI. Recently in the last paper, someone told about the generative AI. Okay, so and somehow you can use the combination of these two technologies also. So when we are talking about a machine learning, a deep learning, a generative AI, and an explainable AI, each and everywhere we all know that the work in each and every sector. So basically we are focusing on an engineering sector. So these all are the technologies, these all are the AI methodologies which are totally implemented in a particular engineering sector. Now this is the first trend, which is basically a predictive maintenance, AI for predictive maintenance. So where we used is in a manufacturing plant, in a power system, in a automotive engineering, in an industry machine. So sometime, as you know that it's a mechatronics, it's again a mechanical field where in today's environment, automobile sector and AI are majorly used. So either that is your manufacturing plant, either that is your power system plant, and automotive engineering, everywhere this predictive, this AI will used. AI, what the things AI predict in these all particular areas, it's vibrations, in abnormalities, overheating, wear patterns, and component failure. Means somehow where we can use the AI in where it may be something, a component of a part of a machine will be failed, it will be detected, it will be implemented with the help of the AI. Now the impact of the AI in this particular trend is the reduced downtime, lower maintenance cost, increase the machinery life, and high productivity. So that was the major impact where we implement the AI in this particular sector, and definitely the impact of this particular AI technology will be reduce your downtime, lower maintenance cost, increase the machine life, and the high productivity will be increases. In Trend 2, that is digital twins plus AI. That means in your turbines, bridges, engine, factories, and supply chain. Everywhere we all know that the AI system will work. Either you can just you can say that it's when you just buy something from the e-commerce portal, and in the same day it will be delivered at your home. So somewhere, everywhere in the supply chain system, which is AI enabled, those particular warehouses where all the products will be kept, again, are AI enabled. So a simulation, optimization, and fault detection, all these things will be detected, will be implemented with the help of this AI. The third trend, that is a generative AI for engineering design, generative design, that is again where we say that a major area of engineering, basically the generative AI, those particular applications we use for this generative AI in engineering sector, that is a CAD optimization, lightweight structure, aerospace components, automotive parts, and product prototyping. These are the applications. These are the few applications. There are a lot of applications will be available where this AI for engineering generative AI will be work. What are the benefits if you use the AI in this particular area? This is a faster design cycle. The cycle of the design, either that is a structure-based design or either that is a you can say that it's a machinery-based design. It will increase the cycle of a design, will be moving more faster. Lower material use, better performance will be increases. So these all are the predictions where we can say that it's a better performance of the system, better performance of the particular product or particular structure will be increases. Examples, just like a weight, cost, and strength will be provided as a constraint when we are talking about the engineer. So these are again the third trend where we use the generative AI. Again, AI in a civil and smart infrastructure. We all know that either we are talking about the smart device, either we are talking about the smart cities, either we are talking about the smart infrastructure. Somewhere we all know that AI-enabled structure and AI-enabled smart cities or smart civil engineering will always work. So basically, when we are talking about this AI in civil area, in civil engineering, the major applications we used, the work where the AI will work, that is a structure health monitoring system. Just in the previous paper, which will be presented by the Aniket, somewhere in the healthcare system, it will be work. Structure healthcare monitoring, crack detection using a computer vision, a traffic prediction system, smart cities, water management, and a disaster prediction. So these all are the application areas where civil engineering and smart civil engineering will be implemented with the help of AI. The major examples again are drone imagery plus ML model detected, bridge damage automatically also detected. So a tragedy, we can stop a tragedy if any disaster be coming. We can predict before the such disasters. So again, the smart civil engineering trend will be work here with the help of AI. Yes. Now we all know that the robotics, definitely AI, that means the robotics kind of everywhere we listen these two words, AI and robotics. So autonomous system, it's intelligent robotics where the engineering applications are warehouse automation. Just I give the example of when we purchase anything in an online environment. At the same time, where the same product will be picked from that particular warehouse and for preparing for the dispatch, and the same day you will get the that particular product at your home. So such type of warehouse automation will be implemented. So there is no human intervention in that particular warehouse. Each and everything, your product ID, on the basis of your product ID, your robots, your warehouse automation machines will pick the product from that particular rake and put that product at the particular packing table, on the packing table, and then preparing for the dispatch. So something warehouse automation applications are there. Industrial robotics are there, where the machines will be operated by the robots. So these such types of things are there. Autonomous vehicles are there, We all know that in many cars there are some auto systems are there. Even without any driver, we can also use such type of cars. Precision agriculture, where the IoT enabled devices, where the AI based IoT structure will be implemented in all the agriculture sectors. So where the growth, the production of that particular crop will be increases, and the quality of the crop will be increases. And the medical robotics, where the robo arm and where mini robot will operate critical surgery also. So that is again the emerging applications areas where we use the robot in daily routine. So robots are moving from programmed behavior to adaptive behavior. Now the next trend, that is AI plus sustainability engineering. So basically sustainability engineering, where we can say that renewable systems will be managed, and sustainability of those particular system will be increases. So energy consumption, carbon footprint, renewable energy output, grid balancing, and the waste reduction. These are the things where we can be put the AI for a sustainable environment. So the examples are again a smart grid, solar forecasting, energy efficient buildings, and the battery optimization. So major challenges whenever we are talking about the AI, yes, we all know that yes, AI is good, but the major challenges when we are talking about the AI for adopting. So in case of technically data quality, because every time every researcher is totally dependent on the Kaggle, where we find the data set and we use the data. Sometimes some researchers never clean the data. They just use the data as it is, which is available at the Kaggle. So sometime you, according to your requirement, according to your parameters, according to your keywords, you have to be clean such type of data. So data quality is definitely a major challenge for the AI adoption. Model biasness, interpretability, and in case of operational, that is definitely infrastructure cost and deployment complexity will increases, and operational implementation structure definitely it's a big challenge for each and every manufacturer as well as a user, how we can easily implement and we can easily operate such type of devices, such type of system which is AI enabled. In case of human challenge, that is a skill gap. Yes, definitely we must have a little bit knowledge of AI and the AI enabled devices, AI enabled technologies. Then we can use the AI in a better way. Faculty training is also required. If we taught to the students, then definitely faculty itself must have the such type of knowledge. Either that is not a bookish knowledge. The faculty must have at least industrial knowledge, where actual implementation of AI will be work. So that after that they can deliver a better knowledge to each and every student. Then curriculum redesign. Definitely, where in each and every sector, you cannot say that it's only in engineering we use the AI. In each and every sector, just like for example from today's presentation and previous two papers, in education we use the AI, in healthcare we use the AI, in engineering we use the AI. So each and every curriculum you have to be redesigned, and everywhere you have to be incorporate AI in that particular system environment. So ethically, privacy, fairness, and accountability will always a major challenge for AI adoption. Now, future skills for engineers, that is a future engineer equals to engineer plus data scientist plus problem solver. So critical skills you have to be required for the AI engineer, that is a Python, knowledge of a Python language, and a data analytics skills. You have to be AI ML fundamentals. You always required a cloud computing environment. How to operate a cloud environment must be required. Domain engineering expertise must be required. Ethics in AI and interdisciplinary collaborations must be required. So overall, we cannot say that it's a simple AI will not replace engineer. Yes, definitely engineers who use AI will replace engineers who don't. So this is the overall concept. of the AI. Now, research opportunities, yes, definitely. From today's conference, somehow everyone use the concept of AI in his or topic, which is definitely a high impact area of a researcher. So that is the explainable AI engineering, physics informed neural network, AI for material discovery, human AI collaboration, AI for climate engineering, age intelligence, AI driven simulation, autonomous manufacturing system, blended learning AI models, AI in education, pedagogy, everywhere in agriculture environment. So there will be a high impact areas for a researcher where you can definitely have an opportunity to research, to increase your research area, to focus on your research area. So overall conclusion of my from my this presentation, that is from machine that operate to system that learn, from product that function to product that think, and from engineering design to intelligent engineering ecosystem. So these all are the things from my side. Now over to thank you so much for listening me, and thanks to GRM 2026 for giving me such an opportunity for interacting with such a huge crowd, huge researchers, and thank you so much.
Dr. Vikas, thank you so much for your insights and wonderful presentation.
Thank you, sir.
Thank you to all our presenters for sharing their valuable research and insights with us today. Uh, so for this session, all the presentation has been done. I would like to thank you, Mr. Norman and Mr. Rahul Manjan, uh, for your valuable time.
Thank you so much.
And we also extended our secure applications to the session chair, reviewers, and participants for their active engagement and thoughtful decisions. The presentations we have witnessed today reflect the innovation, dedications, and collaborative spirits that drive research forwards. With this, we conclude this technical sessions. We hope the discussions and ideas shared here inspired future research and collaborations. Thank you all for your presentations, and we look forward to seeing you in the upcoming sessions of the conferences.
Sure. Thank you.
Thank you so much.
Mr. Norman, please conclude this session.
Okay, this concludes our first session of the Global Research Meet 2026. I would like to express my sincere appreciation to all presenters, keynote speakers, attendees, and conference organizers for making this session a success. The research and ideas shared today demonstrate the importance of collaboration, innovation, also on continuous learning and advancing in knowledge across disciplines. Thank you all for your participation. And we will now proceed to schedule a working break before the next session. I wish everyone a productive and enjoyable conference. Thank you. Have a wonderful day.
It was a really, hey, this is Deepak. It was a really great session. We got so much good insights about all these topics. And thank you, Norman, for hosting and helping each other's for this presentation. Thank you so much.
Thank you for you all. I appreciate this opportunity to share these really important insights. And I I want to share my thankful for you all and have a excellent day.
Thank you.
Good afternoon, everyone. I hope you all had an encouraging experience during these previous sessions. Now it's time to begin technical session 2 of the conference. We are honored to have Mr. Hemang Upadhyay as a session chair of this session. On behalf of the organizing committee, I warmly welcome Mr. Hemang Upadhyay and all the presenters and the participants joining for this session. Mr. Upadhyay brings valuable expertise and experience, and we are grateful for his guidance and monitoring today's presentation and discussions. Now, uh, I invite Mr. Hemang Upadhyay, our respected session chair, to share some opening remarks and formally uh, comments session 2. Thank you. And over to you, Mr. Upadhyay.
Yeah, thank you. Thank you so much, PJ. And thank you so much, first of all, for inviting me in today's session. Um, I have 16 plus of experience into product management and e-commerce and fintech industry. I have worked from consumer to B2B customer experience, and I'm very excited to see today's session. Whatever you guys has brought into this world, and would love to see all the innovations. So thank you so much for your invite, and I'm really excited for today's session.
Okay, very welcome, Mr. Upadhyay, for inspiring words and for agreeing to chair these sessions. We shall now begin with the papers presentation for technical session 2. It is my pleasure to invite our first presenter, Mr. Arvind Balan. Paper ID is 1465. The title is Hybrid Deep Learning Approach of Early Detections of Railway Track Fault to Enhance Railway Safety. The paper ID is 1465. Mr. Balan, are you there? Paper ID 1465. Mr. Balan, are you there?
Is Mr. Arvind available?
I think we need to wait now until we get the next presenter. Okay.
Hey Arvind, hey Mr. Arvind, I think you are not audible to us. Arvind, Mr. Arvind, can you hear us?
Hello, Mr. Arvind. You are still not audible. If you are able to hear me, we are not able to hear you.
Mr. Hemang, I think there's a technical error from his side.
Okay,
Yeah,
that's cool.
yeah, maybe a system error, I'm not sure.
Okay, I think that's fine.
Hello, Mr. Balan. I think there is some technical glitch. You are not audible. Uh, so your video session we will take in the next session. We are going forward with the Mr. Osama. The paper ID is 1468. The title is Machine Learning Based Predictive Maintenance Classification of Industrial Equipment's Failure Detection. Mr. Osama, please present your screen and start the presentation.
Yes, I am in. Let me share my screen first. Okay, good afternoon, respected panel members. Today, I am going to present my research on machine learning-based predictive maintenance for industrial equipment failure detection. This study focuses on using machine learning techniques to predict equipment failures in advance and improve industrial efficiency. So let's move to our very first slide. This research aims to reduce unexpected industrial equipment failures using predictive maintenance techniques. Different machine learning models were applied and evaluated on industrial sensor data. Uh, the study mainly focused on data pre-processing, feature engineering, and model performance comparison, as you can see here. Among all the models tested, XGBoost achieved the best overall performance, 98.4% accuracy. Uh, Here, industries require continuous and reliable machine operation. Traditional maintenance methods often lead to downtime, higher cost, and safety risk. Predictive maintenance helps overcome these issues by predicting failures before they occur using machine learning and sensor data. This improves operational efficiency and reduce unplanned maintenance. Uh, in the literature review, several recent studies related to predictive maintenance were analyzed. Previous researchers used machine learning and deep learning techniques such as random forest neural networks and CNN LSTM models. Although many studies achieved high accuracy, challenges such as class imbalance, scalability, real world implementation still exist. These gaps form the basis of this research. The study followed a structured methodology starting from data collection to model evaluation. The AI 41 2020 predictive maintenance dataset was used. Several pre-processing techniques were applied, followed by featured engineering and class balancing. After that, machine learning models were trained and evaluated using different performance metrics. Let's move on to our very next slide. In the pre-processing stage, the dataset was cleaned and normalized. Smooth was used to handle class imbalance. Two major models, Random Forest and XGBoost, were implemented and compared. The models were evaluated using accuracy, precision, recall, F1 score, and ROC analysis. This slide highlights the important features used for prediction, such as rotational speed, torque, temperature, and tool wear. Feature engineering and pre-processing improve the quality of dataset. Smooth played an important role in improving failure prediction performance by balancing the dataset. The experimental result showed that both Random Forest and XGBoost performed very well. However, XGBoost achieved the highest overall accuracy and better recall performance. This indicates that XGBoost was more effective in identifying actual equipment failures. To conclude, this research successfully demonstrates the effectiveness of machine learning in the predictive maintenance. The proposed framework improved the failure detection, the performance, and reduced the important impact of class imbalance. Among all the models, XGBoost produced the best result and proved suitable for industrial failure prediction. And here, for the future work, The framework can be extended using real-time sensor integration and advanced deep learning techniques. IoT and edge computing can also be incorporated for real-time industrial deployment. Additionally, explainable AI methods can improve model transparency and industrial trust. These slides contains references and research papers during the study. The references include recent studies related to predictive maintenance, machine learning, and Industry 4.0 technologies. Thank you all the panel members for all your time and attention.
Osama, thank you for your excellent presentation and sharing for your valuable research with us. We appreciate your contribution and the insights you have provided.
Thank you, sir.
Okay, the next paper ID is 1459, Miss Susanna. The paper title is Technology Acceptance Models and Consumer Behavior in Digital Project Adoption. Miss Susanna, are you here? Miss Susanna, are you present? Miss Susanna, are you present? The paper ID is 1459.
Audible now? Am I audible?
Yeah, yeah. Yes, yes, yes.
Yes, I will share my screen.
Yes, yes.
Yeah.
And Miss Susanna, please speak loudly.
Am I audible now?
Yeah, yes, yes. Perfect.
Okay. Okay. Hi, I'm Susanna. I'm a research scholar from SSM, and I'm presenting a paper
Susanna,
on
I think
technology.
your screen is not visible.
Okay. Yes. Share my screen. Is my screen visible?
Yes, yes, yes.
Yeah. So, is my screen still visible?
Yes, it is.
Okay. Hi, I'm Anna, and I'm going to present today the technology acceptance model and consumer behavior and digital product adoption. And I'm a research scholar from SSM, and this paper is done by me and my co-author, that is Arvind Balan. Okay, so this paper talks about the rapid expansion of digital products, and as you know, the digital acceptance model is widely used today. And in this paper, we are trying to understand how these parameters of perceived usefulness and perceived ease of use is consumed, and how this will impact our study. So this is a literature review, systematic literature review paper, and we are trying to examine different factors which influence the perceived usefulness and perceived ease of use, and how this technology acceptance model will help us to share, and how the digital environments or the businesses will grow when they have integrated this particular technology model, and how we are going to reshape the consumer behavior, and how these factors are going, and what are the gaps, and how the digital environments will be impacted when we have these factors enabled in the system. So here we are trying to understand that what are the different markets or the verticals which will be influenced, and especially the software influenced markets like the e-commerce and the online shopping platform are trying to enhance the market, and are trying to understand the consumer behavior. So we are just trying to understand in day-to-day life how this technology are emerging with help of the technology acceptance models, and how the consumer will be able to we can grow the market, or how we can understand the consumer behavior based on this. So one of the major vertical or the business area we can say is e-commerce. As we know, our day-to-day life is very much dependent on the e-commerce, whether it is a shopping or whether it is a daily needs. We are widely dependent on the e-commerce market. So this is also one of the very niche area which can have an emerging market if we have this technology acceptance model. The second largest market, what we have understood, is that is a mobile banking or internet banking, as we are very much dependent on the values, and now we do not have much dependency on the hard cash, irrespective of any standards of living. Everybody is widely using mobile banking and widely dependent on that because of the time saving. So even this also have a major impact. Not all the mobile banking sector is successful or digitally improving, because there is a gap of understanding the perceived use of, and there is also a technology adoption model which has to be integrated. Second is artificial intelligence. Again, this is also a very upcoming, like there is a co-pilots, the software industries which are running on AIs. So there is also the impact on how the AI or the patterns will be developed if they know how digitally, what are the gaps or enablements which is coming up in the AI world. And then we cannot say that social media, even the streaming platforms like Netflix and other Disney Hotstar, and this all are completely dependent on the software system integration, and people are more inclined or trying to move towards the social media. That is again a digital transformation which is happening. So we have tried to understand with the existing research that how the existing research have helped us to understand what are the frameworks and how we are going to enhance the system, and what could be the enablers or disablers if we do not understand the adoption or the consumer behavior, and how this is going to impact the different widely used. And these are not anymore, digital is not a luxury, it is a part of daily necessities, and how we can pace our speed, and the business models, how they work when they have the understanding, or they try to incorporate a good variety of variables that is in this model. So our research methodology, we have, as I've mentioned earlier, this is a systematic literature review. We have tried to do a data collection, and the time frame we have taken from 2020 to 2025. And then we have tried to collect the data which is openly from open sources like Google Scholar and Scopus. And we have tried to establish the latest collection, and then we try to remove the duplicates or the literature which is on the repeated thing, and we have done a thematic analysis. So as I've mentioned, the data processing, as this is on the literature, what we try to do is we have tried to identify open sources and published resources. Then we have tried to remove the data duplications and the studies which are very similar to each other. And then we have done thematic categorization on how AI trust or cybersecurity and digital adoption is taking place. And then we have done a comparative structuring. So based on the literature review and thematic analysis, what we have understood is perceived use and perceived use of user is one of the strong elements of consumer behavior and how they adopt today in today's world. Without that, I think WhatsApp is a very good example today, because the ease, it does not stand with terms of how the population is educated or digitally aware, irrespective of age, population, and digital literacy. Based on the ease of use, I think that's how the application is working worldwide, irrespective of whether it is a developed nation or underdeveloped nation. And then there is a trust and security, as I've mentioned earlier. There is a mobile banking. The wallets are coming into a wide utilization, irrespective of the digital literacy. There are a lot of population or a group or a sector of people who are widely dependent on this. So the trust and security is also one of the elements which will decide the factor. And there's a social influence like the social media, and how the people or how the group of population, different age varieties of people are using it. So this also shapes on how widely the crowd is using it. And then there is a AI and engagement. This is for people who are into different sectors of working or corporate or education sector, who are trying to engage it based on how the ease of or probably how this complete factors are enabled in the technology environment. So these are one of the result analysis we have got. And so what I conclude here is whatever the technology acceptance model is widely accepted is because we understand it is based on major factors like perceived use and perceived ease of using. And consistently, we are also understanding that wide markets or verticals which are completely dependent on this consumer behaviors. And based on this only, there is a lot of gaps today where even considering AI being hallucinating, or there is a hacking systems, or the systems getting the software is not working, or the software products or the data products which are failed could be the reasons of trust or emotional value, or the ease of use is not there. So that could be. So what TAM can do is, if we incorporate this particular pillars and try to work on how the emotional or cyber security, or what could be the pillars which is driving the consumer behavior, then definitely the software products can thrive and be successful. And as considering the mobile banking or a healthcare industry, there is again a trust which works on a non-negotiable factor. And there is also a peer review or a social driven factors where the people are driven by understanding, and there is a reference model which runs. And we have a future direction analyzed here. And the future direction says that if we need a digital trust, then we need to work on how good the data is, how the algorithms are designed, and how we can ensure that the development or the building a product is completely based on the relevant factors from this. And there is also future chance of maintaining a blockchain, and there can be a system which is built on data integrations and data lineages based on how easily, not making systems very complex. And then there are different varieties of smart television or AI sensor technologies, which can be getting, whether it can be a sensor, incorporating the hardware and the software together. And that builds an IoTs, and where there is an entire new environment or a house setups which can be built. So there is also a future direction for working on the cyber security, which is a very hardcore part of the technology acceptance model. If the development or the data integrations or the understanding how we are trying to incorporate the security without complicating the system, and ensuring that the structure is internally very strong and complex, but externally it is very easy to understand. And even in a layman language, anybody, irrespective of the group, age, or digital awareness, they can start working on if these gaps are addressed. So these are few references we have taken for this literature review, and I have already mentioned in the paper. So.
Okay, thank you, Ms. Susanna, for your excellent presentation and your valuable research discussed with us. Mr. Upadhyay, floor is open for the question and answer. Please ask some questions.
Yeah. First of all, I think this is very timely topic because digital products now shape everyday life, and your paper usually connects adoption to the trust as of use, and as you mentioned, customer behavior, which is very interesting. Your future direction about digital trust is very important as well. So how do you do your future research where the product is just not depends on the features, right, but also reliability, security, user confidence that we should consider. So how are you planning to do that in future?
So future study, what we can do is it's more of the data definitions. I think the data definitions should be very strong to ensure the cyber security is not compromised. As you know, even it is rural or urban areas or two-tier cities, everybody's life is very dependent on the security system. So we need to ensure that the backend should be very strong. So that's where the basics should be strong. So any algorithm or the software product fails because of the data definitions. I think that we will try to start working on how the data integrations and the impact analysis of the data definition, and then move into how the UI can be very friendly and very understandable with the basic help or a self-explanatory, which any group or any sector of people, irrespective of their living standards, they can have this perceived useness, and that's where the study will go further.
Very, very nice. Yes. And you also made a very interesting topic here, TAM factor. So I would also like to ask, how can companies convert this TAM factor into clear product design decisions, right, rather than just keeping them only at a conceptual level?
Yeah, so I think the TAM, one of in this literature, we have understood there are different technologies, and there are some important variable factors. So any organization, whether it is a startup or it's a big five organization, when they start with any basic product, so they need to first try to understand the intent of the consumer, that is how easily it is perceived, and then they can start integrating the TAM based on this key factors. On the KPIs can be designed on this, and then they can start building the software product.
That was very interesting one. Thank you. Thank you. I thoroughly enjoyed your research work and look forward for future research as well. Yeah, thank you.
Thank you, sir. Thank you so much.
Okay, thank you for the presentation, Ms. Susanna. I think there is one paper also. The paper ID is
Yeah, the
1430.
risk assessment. Yeah.
Yeah.
Please share my screen.
Please share your screen and present that paper also.
Yeah. Let me know if my screen is visible.
Not yet.
Okay, just give me a second. Apologies, spare with me. I'll just try to share my screen again. Is my screen visible?
Yes, it is now.
So the second paper is on the intelligent risk assessment and classification in project management using the data-driven AI model. So this is also again by me and Arvind Balan. So this paper talks about, just give me a second. Yeah. So this paper is again on the systematic literature review. And here we are trying to understand how the digitalization has increased the project management complexity, and how we are trying to understand that traditional risk management is nowadays we are very much dependent on wide patterns and different kind of industries like the construction, the logistic. They are widely dependent on the traditional risk management where it is a waterfall model. So the scope and the budget is designed, and unlike the software industry, we cannot incorporate or cannot afford to have a different patterns of changes or a risk or legal litigations in the project. So that will lead to a lot of risk. So we need to have a risk management in place, which is very gets easy when we have the AI driven decision making or informed decision making. So one of the AI models which we are trying to understand through this literature review is this, where we are trying to understand how this decision trees will help us to ensure at least give a basic understanding of further forecasting or probably a predictive analytics with this decision. And with decision AI, and there's a difference between traditional risk management. Traditional risk management can be little biased or little uninformed and completely dependent on the project managers or the risk team who is experienced and have a historical, but not to something which is newest or something which is very unpredictable or a new issue which can forecast as part of the entire, especially in a stable waterfall or call it a logistic or a manufacturing, which is aviation. So this is where this industries will help. And then we are also trying to understand how explainable AI and cloud computing, or whether it is how we are going to incorporate this literature or this understanding or this paper will help us to give a proper justification or probably a suggestions on how we can improve risk management using AI models or help into data-driven decisions. So again, the research methodology is qualitative and systematic review, as I've mentioned earlier. And we are trying to get again the open sources and published research, which is widely available on the Google Scholar and Scopus. And what are we trying to do is we are in the inclusion is only the peer review studies, and we are not incorporating any other business models, and it is only relevant to the project management and the risk management. And then we are doing a comparative analysis. And for AI algorithm analysis, we are using decision tree, random forest, and LSTM models as, and then we are trying to do a comparative evaluation here in this paper. So as you can see, we have picked a few things here and on the literature review, and we have used references from different papers like Dulata and Remenda, that is 2025. Again, the time period we have taken is 2022 to 2025. And what the results talk about is how AI-based understanding helps in the risk management and the predictive analytics and forecasting, especially in industries where there is a very less scope of incorporating new changes or issues coming up. So in the real world, if we do not have risk management in place, it will accommodate a lot of scope creep and lead to a lot of technical debt. So unlikely in software industry, everybody can go back and make the changes. So that's a reason AI can help us to give up patterns. And again, Christian is in 2026, a recent paper which talks about how AI can reduce the human biases. Like everybody comes from a different industry, and the expertise or the subject matter expert can be biased. So there is a high chances the risk can be compromised or cannot be predicted by certain humans, because there is a limited understanding or there is a limited scope of that person getting exposed to forecasting a certain area of or certain sectors. Then we have Andrew Gilman, that is also on the random forest achieve better prediction accuracy. So this is one of the risk management technique which is mentioned. I think in the later slides I will be talking about this. So this is how they try to analyze, feed the language models into AI, and asked to give a predictive analytics based on the algorithms they run, especially for a very complex environments like the aviation or maybe the construction, where different elements or different variables come into picture for maybe this can be discrepancies to create in the project. And then, as I mentioned earlier, there is also one paper which talks on the language models and how we feed the AI and train the AI, and how it is risky if we do not give a right data set and train the AI, which can not predict or probably give a false or very less likely answers if we do not have our language models in place. So LLM also is a very crucial part when we take AI to give a informed decision making, and it could also lead to a lot of threat or probably completely break the project if it is not given a proper trained AI is given into a place. So the conclusion is, if the AI or the language models which is trained for AI, which can help in risk identification and informed decision making, and also can train a lot of unskillful people, or we can help to improvise or enable a different environments in a way that this can be helpful in the operations or maybe technical or financial, or also helps in a lot of challenges which is unpredictable in a very complex environments. And there is a future technology like explainable AI or a cloud computing or digital twins. It's a real-time analytics. So they are building an algorithm based on the real-time data which is feed in and help us to give a very better risk management system. And however, end of the day, it is only humans who are having understanding will have a better decision when they have a better data or a better numbers or better forecasting on their plates, and that's where the industry can operate in a happy path and be prepared for the upcoming or unforeseen challenges. So for the future work, we have predicted from this literature review is we need to develop an explainable AI model which is self-explanatory, which will give an output or a decisions or help to make decisions which is self-explanatory and with the proper justification, where the stakeholders can take or rely based on not only because the AI is trained, but also it comes up with the proper justification and the data which is fed into it. Then we can also have this future work on integrated real-time analytics and the cloud computing. And there is a lot of scope, especially for the project teams or the risk analysis team, if they can use AI in their day-to-day life. So these are the few references we have today. And other references I've mentioned in my complete paper. So this is all about our paper. Thank you.
Thank you, Suzanne. I think it was very insightful research paper as well. So I appreciate it. I am wondering, like, every product leader, right, agrees that how data is important, and only AI can help if your data is clean enough and in a structured manner. How do you make sure in your research that AI stays reliable when the project data is incomplete or, like, changing as we move further in the project? So how do you make it reliable?
As I've mentioned in the previous slide, scope is on the explainable AI and LLMs. So if the LLMs and the language models and the NLPs are in place, and to ensure that the data fed for the training purpose is on the real-time data, not on something which is data which is manipulated, or the data which is just given it based on the random inputs. I think the data fed definitely a clean data or a reasonable data which is structured can make any AI model successful. And the historical data should be very relevant, and the data validation is required for ensuring the LLM or the trainable models and the AI can be self-explanatory.
I like the focus on actionable AI, I would say.
LLM, yeah, LLM, so that AI have a less tendency to hallucinate or build up unrelated patterns. So I think the training is more important when before using an AI or pitching into, for example, I can say the aviation industry or the medical surgery, or it could be the banking, key investment, or cryptocurrency. So the enablers or the LLMs or NLP should be in place. If the base or the pillars of AI is driven in such a way that it is trained, then there are less chances that AI will fail or give an unrealistic answers.
Thank you. I like that focus on how that is being handled with the architecture and the explainable AI, and also a trade-off between the models, right? Accuracy and interpretability. So I like your take on that. Yeah, thank you so much for your presentation.
Yeah, thank you, Mr. Sharma, for your wonderful presentation. And now I would like to invite our next keynote speaker, Mr. Rajsekhar Reddy. So, Mr. Rajsekhar, are you available now?
Hey, I'm on.
Yeah, so please continue.
Okay, just let me share my screen. Are you able to see my screen? I'm presenting. Okay, good morning, good evening, and good afternoon, everyone. So it's a privilege to be here at a global research meet, and I'm truly honored to deliver this keynote. Today's topic is transforming enterprise data engineering with AI and machine learning, from scalable data warehouses to intelligent decision making. And I'm Rajsekhar Tetla, who has almost 2 decades of working experience in healthcare enterprise data. And currently I'm working as an architect in AI and machine learning area technologies. So today, for the next 15-20 minutes, we'll be discussing on how raw data sitting in siloed warehouses and how it is getting transformed into intelligent systems, making real-time decisions, and how that is making, that giving advantage to patient members or providers, how the cost, how it is helping to reduce the cost. So such kind of details we'll go. Sorry.
So, Mr. Rajsekhar, sorry for interrupting your conversation. Okay, so can you please open your camera?
Sure, yeah. Oh, sorry. Okay, it's good. Are you able to see me now?
Yes.
Okay. So
Yes, please continue.
okay. So let me quickly give an introduction about myself. I'm Rajsekhar Tetla, who has almost like close to 20 years of experience. And my current technologies, I started working from legacy, then Teradata, and now I moved to Snowflake, and I'm using the latest technologies like line graph, line chain, LLMs, GenAI. So, and our main goal is to, at enterprise level, building decision systems and real-time decision systems. So, today's agenda, I'll start talking about, how data engineering got evaluated from traditional to cloud native or modern stack, and what are the different kind of data stack we are using now, Snowflake to ETL frameworks and AI machine learning, and also what are different healthcare use cases, what are different kind of challenges AI is using AI at the enterprise level we are facing, and how it is emerging. Okay, so if we see data engineering is evaluated from 1990s, it is not an overnight change. So from 1990s to early 2000, it used to be very traditional. The legacy systems are mainframe, Oracle, and Teradata. So they used to be very slow. There used to be a lot of batch processing, which they used to run overnight. From 2005 time onwards, Hadoop kick in, and people started, and the data is also increasing slowly compared to early 90s or 2000s. Then we were using HDFS, MapReduce, Hive, Pig, different kind of Hadoop technologies. So the promise Hadoop gave is like it can handle more volume and more parallel processing and more fast. But by 2015, it could not meet the enterprise expectations, though there are a lot of setbacks in Hadoop. That is the time cloud really took over and it started handling all the challenges. Even at the Hadoop level, we still used to have on-prem servers, but when it turns into cloud, everything is pay and use. So there we have a lot of technologies like Redshift, BigQuery by Google, Spark, Kafka, then slowly Snowflake. All these cloud technologies change the entire game. Now it can handle huge volume of data. Why I am stressing data volume is initially we never had this much of volume. By 2023, we have almost 120 zettabytes of data, which is expected to be 394 zettabytes by 2028. And even for healthcare, the way the data is coming in is very huge. So every year we are seeing 36% of growth compared to the prior year. So now AI-driven intelligence systems, like where, as I said, we are using Snowflake, a lot of LLMs, LangChain, LangGraph, all these technologies to take the real-time decisions. And with this, currently where we are now. So it is really helping at industry to scale up the decisions very quickly, and it's not anymore just a reporting system. It is an intelligent system which will help the both users as well as the providers, everyone, with quick decision making. So if we see at the stack of this process, we are starting, there are a lot of sources where how healthcare will receive the data. We'll say EHR, which is electronic health records, electronic medical records. Are there a lot of claim information, billing information, providers information, contracting information, policy information. So a lot of information we'll be getting from various sources. And also now as there are IoT variables are coming in, so it's a live data. Every person is giving it to our systems to track their whereabouts, including their whereabouts, or what is their daily routine, or what kind of exercise they are doing, or what kind of intake they are taking. So all this information. There's a lot of streaming events as well. So using these sources, we need to really ingest the data for our processing, and we have to use an ETL process. For that, like we have AWS Glue, which is a batch processing, Kafka, which is in streaming. And again, we have to build a lot of custom pipeline ETL processing to process this data and to ingest into our system. Once we have this data, then we'll come up with the warehouse. The warehouse can be a Snowflake, which is a multi-cluster. And the Snowflake has a lot of features like zero cloning, time travel. When I say time travel, it will allow you to see the data, how it is to be a few days back, some time back. Like whenever we are updating data, we really no need to maintain multiple copies. Instead, using time travel, it has an internal mechanism where it can go back and look into the data. Then AWS Redshift, which can be used as an data warehouse again. And to load a lot of huge files, we have S3 data lake. And also the architecture we're using is data mesh architecture. Now, once we have data in the cloud warehouse, then our actual analytics and AML will kick in. Here we do have a lot of AWS technology like SageMaker, Bedrock, where we can do a lot of analysis, using which we can generate predictive models. And there are a lot of predictive models currently in market also available. And we are leveraging NLP and GenAI, which can be used for chatbots. And using NLP, we can convert the clinical notes into readable formats. And also, we can still do the reporting using a lot of business intelligence tools. So if I go to AI and ML landscaping, so there are a lot of things, like a lot of areas we can say, like traditional machine learning, which can be used. There are a lot of supervised and supervised models. which can be used to identify risk like anomaly, fraud. When I say anomaly, we can identify how the trends are going. Are there more claims are coming in? Are more users are using a specific kind of billing? Or if a provider is doing any kind of fraud, taking any loopholes of the policy system, are they charging more? So these kind of things we can identify using the machine learning. So next one is NLP and text analytics. As I said, here we can do clinical notes, which can be read into read, which is one of the main source. We can, giving that unstructured data, so we can identify. We can do some kind of predictions. What kind of ICD or CPT codes they are using. This kind of information. Similarly, when we say deep learning, other areas deep learning, where we have nowadays, there are a lot of imaging is happening as part of our diagnosis. So those things can be fed into, using deep learning systems. So we can identify, or the system can help us to diagnosis. So there are a lot of different models like sequential models, transforms architecture, which is really a game changer in the deep learning area. And also multimodal, where when you say multimodal, we can input text, we can input images, everything can be fed to it and it will give the output. And the latest technologies like line graph, which are used to build RAG pipelines, multi-step reasoning, and we can do a lot of orchestration, which is allowing us to do automate a lot of things. And now when we go to LLM and Gen AI, here we can feed the policies and we can compare the policies, how different providers in the market are, helping users, like what is the difference between our system and other system. So, and we can summarize the data. We can use it for chatbot. When we are seeing chatbot, it can be helpful for both members as well as the providers. Members wise, they can, go for tailored products for them, and also they can get the details. And when say provider side, they can get the data quickly, or look into, okay, how much claim is coming, what are the areas it is worsening, what are the areas it is improving, what are the policies they need to consider. So that kind of information as well they can get using these chatbots. And the final thing is ML ops and deployment, which is, we can use to for testing purpose, drift monitoring. When I say drift monitoring, there'll be a lot of changes happening in the real time. So I might have implemented a model today, and there might be some changes happening in the policies or the membership. So I have to keep monitoring how the model is working. Is the predictions is working fine, or do I need to fine tune it? So that kind of drift monitoring we can do. So to do all the things, we have a lot of AWS tools like SageMaker or MLflow currently rightly available in the market. Over to next one. So I'll take a few minutes to discuss about current use cases. So one of the primary use cases is predictive risk analytics. So here we see in industry where there is 87% prediction accuracy. So here basically how industry is using the risk analytics is to identify what kind of a person has, like, based on his previous medical history or his habits or is based on his geography, what kind of things, what kind of diseases he can get into, like what is the chance of getting a heart stroke, what is the chance of getting a kind of viral fever. So that kind of predictive analytics we can do, and which will help us to proactively take or outreach the member and give him suggest the medication to avoid. So this will reduce the cost for the members, and this will reduce the cost and help the this will reduce the cost for provider or the insurance giver, and also help the members. And also it will help to reduce the claim fraud as well. When I say claim fraud, nowadays there are a lot of providers using, in fact they're also using AI to identify the gaps in our policies, and they're charging more, or they might be charging to the users and then also charging the insurance. So this kind of things we can identify using claims fraud detection. And also, when I say there's one more use case, personalized member experience. So we do have different policies where the insurance provider will reach the members, and they will give different kind of programs based on the programs, how their health is improving. We'll track it. Then based on that, we can tailor the programs, and we can reach out to the each different members. So this will help to reduce the cost for the members and also reduce the cost for insurance, and also optimization. So this will help to take better productivity, and this is helping the productivity increase by almost 40%. So when we say all these different use cases, the main goal is to reduce the cost. So it can be for the insurance provider, also the members. So which is the main driving factor to have different kind of use cases. So I'll take a minute to identify what kind of steps we are doing. So first we'll take a raw ingestion. What of data, whatever we are receiving, we'll do ingest into our data lake using ETL. Once we have the data in the ETL, then we'll do a lot of feature engineering to identify what kind of features we have to consider for our models. Then we'll go with model training, where we'll do SageMaker, XGBoost for the different kind of models we'll do based on supervised, unsupervised, or sometimes we'll go with deep learning or NLP. Then once we have the models ready, then we'll go with either the model can be called as an API or in batch process. Sometimes we need real-time decisions quickly. So that times we'll have an API call and we'll get output. So these things are mainly used for the decisions. So when we see the industry trend, so the readmission prediction is coming to 87%, and the highest thing is to detect the fraud. We are able to restrict fraud by 93%, and next higher thing is the prior auth approval, which is 91%. So before, when sometimes when we reach to the provider, they might need a prior authorization from the insurance. So that can happen real time. It is almost hitting 91% accurately, which is very very much helpful for the members, so that they are able to get the services quickly. Earlier, which is used to take a lot of time. So I'll just go how LangChain and LangGraph are working. So LangChain is mainly in the chain. It's as the name says, it's a chain where the things will go happen in. Most of the things will happen in sequentially, but some things we can do in parallel as well. It helps mainly to the RAG, which is retrieval augment generation. Some of the data we don't have it, so we might need to get it to internet, other external systems, so which can happen through LangChain. And also it can be used for easily integrate with APIs, databases, everything. So mainly we are using a lot of healthcare policies to analyze and see how the things are happening. And when it comes to line graph, which is also a little advanced, I can say, or maybe different kind of use cases. So using which we can do prior authorizations quickly, and we can do a lot of parallel processing, agent execution. We can go over it. I know I'm going a little over time. Let me try to make it quick. So far, whatever I discussed are only advantages. So I should say what are the challenges we are facing in the industry. The first one is data quality and governance. I heard a couple of folks who discussed in previous papers also mentioned it. So AI is not cannot do miracles if we don't have good quality data. So quality of data is very much critical. So we are having different sources. So we have to identify a way that is called MDM, Master Data Management, which can unify our different systems into a unique way. So that can be helpful for our analytical purpose. And the second and most critical is high security and privacy. As it's a healthcare data, we have to follow the HIPAA rules to ensure we are not exposing any personal information to public. So when we say AI models. And the next one is scalability. As data is growing fast rapidly, we have to really improve, or we have to consider the scalability, especially to avoid impact on the performance. And the other thing, model drift and reliability, which I touched earlier. So as the things are changing rapidly, we have to ensure our models are not outdated. We have to fine tune them on a timely basis. And change management is, a lot of changes are happening in the adoption of AI tools. So that also we have to catch up. So interoperability is in HL7 fires integration with AI systems. So all these are challenges which we have to have some guardrails, and we have to take care from the day one when we have decided to integrate AI into uh, our system. Otherwise, down the line, it will be a huge problem, and whatever we are doing will simply go for a paste. Okay, so when I compare traditional architecture with when it's intelligent flat data platform, which I'm calling as the AI system. So traditional architecture is, as I said earlier, it is most of the things are batch. That could be monthly, daily, and they are a siloed data warehouses. They are not interacting with each other. We have manual data checks, manual testing, manual decision taking, and weeks to deliver insight. So once we have the data, by the time we process, things are already happened. We always go back and see, retrospective. We never know predictive. But when it comes to intelligent, it is always a real time we can do. We can automate the process. We can do predictive analysis, and it is just seconds to minutes to seconds to take actionable insight, which is improving the cost, which is improving, reducing the manual effort almost by 60%. It is like 3 to 5 times faster than the traditional one. And I'll touch on emerging trends. So there are a lot of things happening currently. Like if I say AI native data platforms, like Snowflake and AWS Bedrock, everybody is coming with their own integrated models. So like unlike the current system I mean, when I say current system, unlike yesterday where we have to do our own ML process and integrate with the data, now the models are already integrated within the data warehouse platforms itself. So it is happening very quickly, and it is helping us to develop on a rapid pace. And there are a lot of multi-model AIs are coming. So different ways where we can combine everything. So agentic AI workflows, which are really a game changers. So which are allowing us to automate everything, generate, create a lot of agents. We can create we can integrate them for quick decision. And responsible AI and ethics, which is very crucial. So as being it's a healthcare, we cannot simply go some model which is a black box. So we should be able to explain why things are happening, especially to get the gain confidence from users and the providers. So which is where a lot of models we are focusing how we should be able to provide the response explainability. And there's a lot of gap between academy and industry in the current time frame. So academy is short of real-time data or real-time issues, whereas the industry's lack of upcoming changes or innovations. So if academy and industry both integrated and both closely working, that will help us to do a lot of innovations. And also it can be done through a lot of internship, fellowships, or sandbox, where academy people can access the industry data, and industry can take advantage of academy changes which are happening. So the key takeaways from this discussion is like we have to modernize and make sure our data is very qualitative. And second thing is AI is a strategy, it is not a tool. So using AI strategy, we have to identify the use cases, what can be done, how it can improve. Then we can make a we can get into that direction. And healthcare is them looking for a special attention, because there are a lot of restrictions on HIPAA and PHA protection and model expandability. So those things we really need to focus and put some guardrails. And upcoming technologies like LangChain, LangGraph are really evolving a lot, and it is the game is changing rapidly, so we have to take advantage of these technologies. And last but not least is what matters. So there's no point in developing something which is not really useful for the end users or the providers. So we have to even if it is 99% accurate, and if we are not able to make advantage of this, then no point. So whichever things are really needed, the use cases, we have to identify, we have to define the business KPIs, and we have to focus on that area. So, and finally, thank you for giving me this opportunity to go over all my experience, all my so yeah. So yeah, finally, I would like to thank you for giving me this opportunity, and looking forward for the further.
Thank you so much, Mr. Rajsekhar, for giving your wonderful presentation. Okay. Now we can move forward with the presenter. So the next presenter is Aniket Naresh Bachao, and the paper ID is 1453. So Mr. Naresh, are you available?
Yes, I am available.
So you can present your screen and please continue.
Let me share my screen. Yeah. Is my screen visible? Hello.
Yes, your screen is visible now.
So, good morning, everyone. My name is Aniket Naresh Bachao. Today I am presenting my research work on leveraging AI-powered business intelligence for data-driven decision-making in retail industry. In this work, we use AI and deep learning techniques to improve the retail sales, forecasting, and business decision making. Let's move to the next slide. This is our table of content. So in this presentation, we are going to hover through the abstraction, introduction, literature review, methodology, result analysis, discussion, conclusion, and future direction. And our final stop will be the references. So let's move to the abstract. As we all know that the retail industry generates a massive amount of the business data every day. So the traditional forecasting system often struggle to handle the complex and dynamic retail data. To solve this issue, the research proposed a hybrid ensemble of RF plus GRE model. In this model, the random forest is used for feature extraction, while GRE is used for sequential learning and forecasting. The proposed model achieved an R-square value of grouping 94.5%, while outperforming the traditional models such as linear regression, SVM, RNN, and ANN. That's introduction. Due to the digital transformation, the retail business now generates a huge amount of customer and sales data. The traditional business intelligence system face difficulties when data sets become large and dynamic. Artificial intelligence, machine learning, and deep learning techniques can help in business improvement. They can help in sales forecasting, inventory management, customer analytics, and making the operational more efficient. These technology help retailer make faster and smarter business decisions while improving their competitiveness. This is our literature review part. As we can see, these tables summarize the recent study related to AI and machine learning in the retail industry. The different researchers used different techniques such as MLP, random forest clustering algorithm, CNN, and K-means. Most studies achieve good prediction, but contain several limitations, some of which are high computational complexity, limited hybrid models, scalability, and weak performance on dynamic data. Based on these limitations, our research proposed a hybrid RF plus GRE model to improve uh, the production. Uh, this is our methodology part. For the research, we used Kaggle retail sales data set. Then data set is being pre-processed. In pre-processed, we manage missing value, remove duplicates value. Then the data is moved for feature engineering. In feature engineering, we will change the non-numerical value data into numerical value by using one hot encoding. Then the feature engineered data then goes to the normalization part, which is normalized. Then the data is split into two parts, which are training part and testing part. The training part occupy approx 80% part, while the testing part is 20% of the total data. Then the model is applied to the data, and then model is evaluated through evolution process such as MAE, RMSE, and MSE, and R square also. This is our result analysis. Uh, as we can see that the table shows the performance of proposed RF plus GRU model. The model achieved a R square value of 94.5%, MSI of 79564.47, RMSE of 282.07, MAE of 134.62. The high R square value indicates strong predictive capacity, while lower error value show the better forecasting consistency. These results demonstrate the combination of random forest and GRU improve the sales prediction and accuracy efficiently. Let's move to the next slide. This is our residual plot. The figure shows the residual plot of RF plus GRU model from year 2013 to 2018. The residual are evenly distributed, which show that there is no major pattern in the data, means in the result. This indicates that the model has don't have the temporal wise. Prediction errors are random and model are reliable over time. Let's move to the next slide. This is scatter plot show residual versus the predicted value. The points are randomly distributed without any visual trend or structure. This is our comparison table, which compare the proposed model with existing machine learning model. Among all the model, the proposed RF plus GRE model achieved the highest R square value of 94.5%. This demonstrates that the hybrid ensemble model perform better in retail sales forecasting compared to the traditional ones. The RF plus GRU ensemble combine the feature extraction capability and temporal sequence learning. This helps the model to capture non-linear patterns and sequential dependency in retail data. As a result, forecasting becomes more accurate and business will support conclusion in future work. In conclusion, this research proposed a hybrid RF plus GRE model for retail sales forecasting. The model achieved a high prediction accuracy with R square value of 94.5, reduce the forecasting error compared to existing models. These systems can help retailers to improve business intelligence and data-driven decisions. In future, the model can be enhanced by integrating real-time customer behaviors, market trends, and economic indicators. This is our reference containing all the material we used. Thank you everyone for your time and your attention.
Hello. Yeah, thank you, Mr. Aniket, for giving a wonderful presentation. So, Mr. Rahul, do you have any questions? Would you like to ask some questions?
Sir, I think you are not audible.
Yes, thank you for presentation. As of now, it's there is no question from my side.
Okay, thank you. So, we can move forward with the next presenter, Mr. Dinesh. So, Mr. Dinesh.
The paper ID is 1477 and the paper title is A Robust Machine Learning Architecture for Accurate Malware Classification and Large Scale Cyber Threat Data Set. Mr. Dinesh, if you are there, so please share the screen and present your paper.
Yes. Is my screen visible and is my voice audible to everyone?
Yes, sure. It's good, Dinesh.
Hello, everyone. Good morning, good afternoon, and good evening, wherever you are. My name is Dinesh Rajashekaran. I have 2 decades of experience in cybersecurity space, specifically in identity authentication, authorization, API-related security. I have built a lot of developer tooling and integration, data integrations, and data layer. I hold multiple US patents in the cybersecurity field. I'm super excited for this session. I want you to take you through a robust machine learning architecture for classifying malwares accurately, even at the scale of millions of files. The key question that is driving this work is simple. As cyber threats evolve faster than ever, can we build detection that is both fast and accurate? Over the next 15 minutes, I'll show you that the answer is yes. And then here is how I was thinking I'll walk you through this. We'll go through the problem statement, why it matters, and walk briefly through what others have done in this space. Then spend most of our time in our methodology and results, which is where contribution really lives. And then we'll close on the next steps. So malware is one of the most serious threats to information systems, and it's evolving constantly. So we need detection that's both fast and accurate. We built a framework on Ember dataset, applied carefully pre-processing and exploratory analysis to clean up the data and sharpen the features. And we trained 2 classifiers. We trained a random forest model, and then we also trained a multi-layer perceptron, a neural network model. The neural network clearly won. So it reached a 97.6% accuracy with a 99.1% AUC, beating random forest with the 94.7% accuracy. And when we benchmarked against other published methods, our came out on the top, giving a scalable, reliable classifier for real cybersecurity decisions. So why does this problem matter? The digital surface attack has exploded. We used to have cloud, mobile, IoT threats. Now we have AI-related threats. And then malware now threatens critical sectors like healthcare, finance, energy, even public sectors. The trouble is that traditional antivirus is signature-based. That's the core of the problem. It's a signature-based, which means what? Which means it only recognizes malware that the model has already seen it before. It's effectively blind to zero-day attacks. It is blind to modern variants that use encryption, polymorphism,
obfuscation, masking that constantly change their experience. Worst case scenario, sophisticated malware can detect when it's being watched in a sandbox and simply change its behavior to slip past. So the conventional approach is fundamentally is lacking. This is exactly where machine learning helps. Instead of matching known signatures, machine learning learns the underlying patterns and anomalies that distinguishes malicious from benign. Which means what? Which means it can generalize to threats it has never seen before and scale to huge volumes of data. Before we started our work, I started my work on this. A lot of research tackled pieces of this, and then we took an inspiration from previous works. Across the studies, classic models like SVM, random forest, and decision trees generally landed in mid-80s and mid-90s on accuracy, while deep learning approaches pushed towards 96%. So the field, the industry in general, clearly trends towards neural methods, but each has a catch. Some suffer from a low precision and recall. Others overfit during hyperparameter tuning. Several were narrow limited to either Android or IoT or just SMS related malware attacks. And the deep learning winners were computationally very heavy and not pragmatic. It's hard to run in real time. The common thread in their future work sections build something more general, more scalable, more accurate. That this is the gap. So this is the gap which my work, our work is related to fit here. So how we build this? 3 stages. The first stage is data and exploration. So we used Ember about 1.1 million Windows PE files. That scale matters. It's why the results are credible. We ran exploratory analysis to understand the class balance, the feature patterns, and which attributes actually carry signal. That's the first part. The second part is pre-processing. We removed invalid samples, grouped and labeled encoded features, standardized the data, so no single feature dominates, and the split is 80-20 ratio, right? So into training and testing. Clean inputs are what make the downstream models trustworthy. The third stage is the models itself. So random forest is our strong baseline. It combines many decision trees which boost accuracy, resists overfitting. Our proposed model is multi-layer approach, a neural network with hidden layers, RELU activations, the Adam optimizers, backpropagation, that gives it the capacity to learn the complex non-linear patterns that separate malware from benign files. So in the figure 1 flowchart, what the picture I'm showing here is where you can see the flow, right? So data is in the preprocessor, train both models, and then evaluate is the whole pipeline. And this is the whole glance of the pipeline. The key takeaway is 1.1 million PE files. We clean processing neural network built to capture the nonlinear malware patterns. A quick but important point. How do we judge success here? Accuracy alone is misleading in security because missing a single piece of malware can be catastrophic. So we evaluate on 5 metrics, the whole model. 1, accuracy, 2, precision, 3, recall, 4, F1 score, and 5 AUROC metrics. Together, these tell us not just how often the model is right, but how well it catches actual threats, and then how confidently it separated the 2 classes. And then keep these 5 in mind for the next slide, the 5 metrics. And then this is also one of the heart of this presentation, the results. Looking down the figures here, the MLP reached 97.6% accuracy. 98.8% precision and 95.4% recall on F1 and 99.1% AUC. That precision number, 98.8% precision, which is what you're seeing here in this slide, means very few false positives, false alarms, which is what keeps a security team from drowning in noise. It really scrutinizes a lot of false positives and noise. And the 99.1% AUC means it separates malware from benign almost perfectly across thresholds. On the figure 2 here, the confusion matrices confirm it, right? The errors are few and balanced, and the training and validation queues track each other's closely, which tells us the model converged cleanly and isn't overfitting. In other words, these numbers should hold up on new data. So that's the accuracy of numbers here. We compared against decision trees, logistic regressions, KNN, and even GPT-2 transformer approach. The published ranges from about 69% for logistic regression up to 94 to 95% for strong deep learning model. Our MLP at 97.6% sits at the top of the table, ahead of every comparison method out there, including the transformer and LTSM, which is here in the figure. The ROC comparison makes the gap visual. The MLP curve has the top left corner, what you're seeing here on the picture here, which is exactly what you want. So the contribution isn't just a model that works, it's a model that outperforms the current best across the board while staying lightweight. So let's bring this all together, what we have seen today. We built an MLP-based malware classifier that has hit 97.6% accuracy with 99.1% AUC, beating random forest and outperforming a wide range of established methods from logistic regression and SVM to LTSM and BERT-based GPT-2. The takeaway is that a well-engineered neural network trained on clean, large-scale data delivers both the accuracy and the generalization that evolving cyber threats demand. So what's next? Where would we take this work from here? So we can go in 3 directions. First is a real-time deployment, moving from the lab to a live environment. So we want to make this industry-wide. Second is adaptive learning that keeps pace with the zero-day attacks, even the current Mythos 2 and all. And the third is integrating explainable AI and hybrid architecture. So the system isn't just accurate, but also interpretable. So it's understandable and then trustworthy to the analysts who rely on it. And then there is a broad literature. So there is a lot of work that went in, not to go through line by line, but in general, there is a lot of work happening in industry on this topic. We refer to a lot of the existing work and all. That concludes this presentation. I really appreciate this opportunity and then open for any questions.
Thank you, Mr. Dinesh, for the wonderful presentation. I would like to invite Mr. Upadhyay and Mr. Rahul Manjan, sir, to ask the question.
So one quick question, Mr. Dinesh. It was a really great insights and mainly towards the importance of a malware attack. So a couple of insights, if you could share, is like the influence of the hardware placements. Like there are the dedicated hardwares, also participants of this protection. So can you please share your expertise, how they are and where do they really participate in terms of hardware? And second is the digital data which is not over the network. Some data is resident to the hardware specific. So is this the target uh, subjects or the target to the malware attacks also?
Yeah, no, that's a great question, Rahul. First of all, the hardware, you brought a very good point. Hardware itself is evolving from the local CPUs to the CPUs what we are seeing in cloud data centers, all the way up to now the AI-centric CPUs where the GPU is built in memory with the CPU itself. In general, the pattern what we have seen is um, the memory component of the CPU and then malware, there is a correlation to it. The more the memory component and computational component is built into the silicon, the less the malware attacks are. The traditional CPU architectures, hardware architectures, the memory component modules, SSDs, the way they were placed around, they played a very big role. Even to that extent that the ransomware attacks and all were taking over the entire hardware. So the structure of the hardware itself is matters a lot. The good news is the now more and more basically the large AI-centric CPUs and GPUs, the way they are evolving, they are agnostic to whatever is being out there in terms of malware related attacks. So that is a good news. The bad news is the reciprocity itself with the brute force attacks and all happening with AI, even to that extent that companies like IBM are making quantum chips which are cloud based now. Like anybody can go sign up and then use quantum to break the encryption and all. So they are actually bringing new attack patterns. That's the reason why towards the end of my presentation, I said that we need to really evolve into the non-deterministic models.
Yep.
That's all. Hello?
Yeah, thank you. Thank you,
Thank
Dinesh,
you.
on this side. So your presentation is very insightful and very, the topic is very interesting as well. So just interest of time, I would just ask a quick question that I am wondering about. So the model that you basically described, right? I'm wondering how it would perform on an, let's say, new malware families that is being introduced, which is not part of a training data. So how would that perform?
Yeah, that's evolving for all the right reasons. The one of the next steps, what I said is to your point is how can we measure this across new hardware Mr. Mahajan was asking, and the evolving attack patterns. Like for example, talking to something like Anthropic Mythos, getting some of the data elements from Mythos and then running through it and then do it. Now the good part is towards the end of the presentation, I was showing you that the accuracy and precision of the model. So with the sample what we have used, 1.1 million, I'm pretty confident that it has a better neural network than anything out there to date. Also, what we do not know is what we do not know. Unless we take it to across the industry and then run it across the non-deterministic attack patterns and the data sets, and also across the industry verticals, right? So we need to train it with the variety of telecommunications, healthcare, financial, fintech, public sector data. We do not know the actual results of it. So far, it's good. And then we'll know more once we start running it across the different data sets. But I'm pretty confident that it will scale.
Makes sense. Makes sense. Yeah. Thank you, Dinesh.
No, thank you all. I really appreciate the opportunity. Back to you.
Okay, thank you, Dinesh, for your excellent presentation and for sharing your valuable research with us. The next paper ID is 1466 the machine learning based condition monitoring of wind turbines using SCADA dataset for early fault detection. Mr. Arvind Balan, I am presenting the recorded session. Um, is my screen visible? Yeah. Okay.
We can't hear him talk.
Sorry, no audio from the recording.
Yeah, there's no audio that we can hear.
Now I will Now I would like to invite our respected keynote speaker, Mr. Karthik Bhoja, to deliver the inaugural address.
Sure. Thank you very much. Let me share my screen. Are you able to see my screen?
Yeah.
Okay. Thank you. Okay. So good morning and good afternoon, everyone. So it is really pleasure and to welcome you all for today's keynote session with me. And so I'm going to talk about DevOps with AI automation and building intelligent and self-healing cloud systems. So, and my name is Karthik Boja. So, and I'm currently serving as a senior enterprise software engineer specialized in cloud engineering, DevOps, platform automation, and infrastructure as a code. So over the past several years, had opportunity to architect, implement, and scale the cloud architecture solutions in industries. And so today I'm going to talk about how DevOps is evolving into intelligent self-healing systems using AI automation and for transforming software delivery with intelligence. And so we are moving from traditional CI/CD pipelines to systems that detect, decide, and fix themselves. So hope you guys can able to hear me and not like a previous. Okay, let me give the presentation. Okay. So DevOps is no longer just a CI/CD pipeline. It's about building a system that can detect, decide, and fix themselves automatically. So with the rise of AI, we are moving towards self-healing cloud systems where failure don't wake you up the middle of the night by 2 a.m. And the systems can able to fix themselves. So if your phone is buzzing in the middle of night, so there is a problem in production. So spend the next 2 hours looking at the logs, trying to figure out which update caused the crash, and eventually it just restarts the services. So right now, we are using a lot of automations. So we have scripts that do things for us, but scripts are really stiff. So the only work, the problem, so explicitly that can proceed. So if something is really weird and the script fails, you have to get into the call and then fix the issue. So we need to move away from just running the scripts and start building systems that is really smart enough to fix themselves. So I would like to explain some of the problem statements and how we can able to resolve those kind of issues. And so right now, in a traditional DevOps environment, so we were following the model as a DevOps as a reactive model. So even with automation, so humans still investigate and fix the issues that, and the feature of system that handles this kind of automation. So in traditional DevOps, we usually have a monitoring tools that detects the issues and alerts are triggered, engineers investigate, and fixes are applied manually. So with the problem statements, this leads to high mean time to react with repetitive efforts and human dependency, even some production risks. Like for example, like if you have a kind of service principal secrets which can able to cause outages. So those kind of problems we've been using to face. And in the future, so the scripts will automatically take care, or the AI will automatically take care of like removing those kind of secrets, not breaking the productions. So AI-driven DevOps, how we can able to advance into the AI-driven DevOps. So AI introduces anomaly detection and predictive analysis. It's good at doing that. So even it is good at auto remediation and continuous learning. So we move from automation to autonomy, from reactive to predictive systems. So the AI in DevOps introduces intelligence into the pipeline, like the key capabilities are like anomaly detections, like which identify unusual behavior. If it is a predictive analysis, it prevents failures before they occur. And there is an example like if it is really good at doing auto remediations and it fix issues without human intervention. So AI is good at continuous learning to improve over the time. So think of it as from automation to autonomy. So what is a self-healing system? So let me get to the next slide. So when I say self-healing, so I'm not just talking about the system that acts like a human doctor. It watches closely. It doesn't just wait for the crash. It looks from small changes like a service getting a little bit slower than usual, and it understands why. So if using AI, the system can look at millions of lines of data and say, hey, this is happening because of the update we did an hour ago. So like that. So it takes an action. It doesn't just send an email. It tries to fix it, and it might turn off the broken part, switch to a backup, and go back to the older version of the code. So that is somewhere we are trying to fix the issues to act like a self-healing system. So how we can build the DevOps way for the AI. So if you are a good DevOps engineer, you don't need to be a scientist to do this. So you just need to build a loop, let's say, so get better data. We need to see everything, not just either service up and running, how the data is moving. So use AI to spot patterns. Humans are really bad at looking at 1,000 graphs at once, but AI is great at doing that. So you have to utilize uh, its maximum efficiency. So every time these specific things happen, the system crashes 5 minutes later. It's going to take care of itself. Build the kind of a safety net. This is the most important part where you go to the AI set of tools and you tell it you can add more memory if you get busy, and you can undo a bad update, but you aren't allowed to delete anything important. So those kind of things you have to train AI such a way that it takes care of itself. So trusting the machine and with the real world problem solutions. The biggest worry where engineers have is what if the AI makes it worse? This is why I talk a lot about the examples like if the system does not does something, it has to tell us why if within the plain test. If it restarts the service, the log shouldn't just be a code. It should say, I restarted this because was it using too much memory and about to crash. So those things, it need to be giving a very clear example. So when you have to a clear explanation, we can trust the system. Like we stop being fighters who run around fixing leaks, and we can start being architects who build the pipes so they are never leak in first place. So that's the kind of model we need to. So in terms of architecture, so the self healing system includes observability layer, which has logs and metrics. So, and it also has the AIML layer where it detects the patterns, and the decision engine, which has the rules plus AI. And that layering is going to help you out in terms of adding your automation layer. So this architecture loop will help you out, do the detect, analyze, decide, and act and learn. So this is the way how we need to architect the things in such a way that we can use maximum out of AI. So without human intervention. When it comes to real world problems, the in let's say I'm going to take an example of in Azure and GitHub environment. So I already said the service principal secrets get expired and cause application failure. The manual rotation leads to inconsistency and downtime. So that will be handled with the help of AI. So, and the primary way how the solution is going to implement is we implement the automation secret rotation system detects expiration and generates new secrets using Azure CLI within the JSON format if it is required and stores in a keyword. So this is going to be a self-healing behavior when you try to automate it like that. So if GitHub updates any kind of failure or system repairs, if it mismatches occurs, it will help you out in resyncing by itself. So that's the kind of behavior when you try to add the self-healing architecture to the system. So when it comes to outcome, so there will be no manual rotation or zero downtime, and kind of secrets get expired. Like consistent updates across all the environments is going to be taken care by itself during the middle of the night when you kind of not available, not able to respond. So the future of AI, AI can predict credential misuse, detect anomalies, or it can able to automatically trigger remediation. So I want to just wrap up and close up my note. So the goal is to just let a robot run your whole company to get rid of the boring, repetitive, stressful parts of being an engineer. So when the cloud can heal its own simple problems, we get our speed back, our systems stay online, we can spend our time being cool instead of fixing old mistakes. So the future isn't about working hard, it's all about making our system work smarter for us. So DevOps is evolving from manual operations to automation to intelligent self-healing systems. So we must build systems that think, adapt, and heal themselves. Yeah, thank you very much for this.
Thank you, Karthik.
Hello.
Is this, I think Matthew is next. Oh, sorry, Ankur is next.
Yeah, first, welcome Satyam. First, we conclude this session, the session second, and we are very thankful for the Karthik, Mr. Karthik, for Hemang Upadhyay, for their valuable time. So, very thankful to both of you, sirs.
Thank you. Thank you so much. And thank you to all the presenters for sharing thoughtful and relevant research across AI, machine learning, and security healthcare today. I really enjoyed all the session, and I appreciate the range of ideas shared today from predictive maintenance and consumer behavior and malware detection, which was very interesting one, and retail intelligence. So wishing all the presenters the very best as you guys continue to develop this work further. And thank you so much. I really enjoyed.
Thank you so much, sir. Thank you to all the presenters and the participants for making this session informative and engaging. We appreciate the valuable research contributions and the participants to everyone involved. With this, we officially conclude this session. Thank you all for joining us, and we wish you a productive and enjoyable conference experience ahead. Thank you so much, everyone.
Thank you. Yeah, so I'm a session chair for this next session. Should we take a 2 minutes break, or should we continue? Or I think Mr. Ankur Chauhan is the next one who should be presenting.
Give me a minute. We can start the session three with the introduction and some overview. So, give me a second.
Sure.
Good evening, everyone. Welcome to session 3 of day 1. I am delighted to host this session. We are honored to have Mr. Satyam Nikra as our session chair. Sir, thank you for your valuable presence.
Thank you.
I now request Mr. Satyam Nikra to kindly start the session and share his opening remarks.
Yeah. Thank you everyone for being present here and presenting your research. Um, yeah. So I see like AI is evolving very fast, and then see good lot of good research happening in this area, and particularly I'm in Bay Area, so a lot of different opportunities are coming up in the field of AI, and a lot of breakthrough changes are also happening because of the AI in these days. And I'm really excited for you guys to present your research in this area. Um, yeah, so yeah, should we get started?
Okay. Yes, thank you, sir, for your encouraging words. Now let us begin with our presentations. Okay, so I would like to invite Mr. Ankur Chauhan to present his research paper ID GRM 1476 titled FinTech Credit Scoring Systems and Financial Accessibility for Small Businesses.
Uh, Hello, everyone, and good evening. Today, I will be presenting my research on the topic FinTech Credit Scoring System and Financial Accessibility for Small Businesses. Well, in
Ankur,
this present, yes,
Ankur, please
hello,
open your camera.
is it okay now?
Yeah, please continue.
Okay, so as you can see, just wait, hold on. Wait, actually, my system got hang. Okay. So this is the title on which I'm going to give you a presentation. The title is this FinTech Credit Scoring Systems and Financial Accessibility for Small Businesses. So in this presentation, uh, I'll discuss how technologies like artificial intelligence and machine learning are changing the way lenders evaluate borrowers, and how these innovations are, helping small businesses like SMEs to gain better access to finance. So let's move on to this next slide. So this is basically the first slide, which is the abstract. So in abstract, we have we can clearly see that traditionally when businesses apply for loans, banks look at things like collateral and credit history and financial records. So you can see the problem is that many small businesses, they don't have a strong credit histories or enough assets to offer as a collateral. And here you can say this is where fintech comes in to the account. So this is basically the point where fintech takes the in charge and takes care of everything. So we can say this fintech companies use technologies such as AI, machine learning, big data, and blockchain to determine the credit worthiness using alternative sources of information. So through this study, I explored how these technologies improve lending decisions, increase financial inclusion, and what challenges they create in terms of ethics, regulations, and cybersecurity. The overall findings suggest that fintech makes lending faster, more accessible, and more accurate. Moving on to the next slide. Okay, let's talk about introduction, like a very basic introduction. So before discussing fintech, it's important to understand why SMEs are so important. So first of all, I would like to say that SMEs play a very major important role in creating jobs, supporting innovations, and contributing to economic growth. However, many SMEs they struggle to get loans from traditional banks. Uh, some of the common reasons you can say, like lack of collateral, limited credit history, and insufficient documentations. So as a result, many potentially successful businesses are unable to access fundings. Fintech platforms addresses this problem by using digital lending systems and alternative data sources, making credit assessment more inclusive and efficient. So this is the basic introduction which I have prepared. Let's move on to the literature reviews. So these are the findings of the authors, like authors who have gave their findings in the previous publications, like in various journal articles and various papers and theses. So basically, this is the literature review, and these are the key research findings which I have extracted from various sources. So as you can see, that to understand the topic better, I reviewed these several recent studies. So the first study, as you can see, this Pooja, in 2025, she found that AI and machine learning improve credit scoring by using data such as utility, bill payment, and online activity. And you can also see this Bileto and this colleagues. They showed that machine learning models often predict credits risk more accurately than traditional methods. Other researchers, they have also found that digitalization, it helps lenders better evaluate SMEs by reducing information gaps and improving decision making. So overall, as you can go through all these literatures, it is clearly visible that these literatures strongly suggest that AI-based credit scoring improves lending accuracy and increases access to finance for small businesses. So this is the literature review. Moving on to the next slide. This is the research methodology. So basically, what research method I have used in my study. So this is all about. So this research is based on a literature review and critical analysis of studies, which are published between 2019 and 2025. So basically, my study was guided by four theories, like four key theories, as you can see here. The first theory is related to information asymmetry theory, which explains how technology helps reduce information gaps between the lenders and borrowers. And the second theory is financial inclusion theory, which basically focuses on improving access to financial services. The third theory, we talk about the technology acceptance model. So this is the most important theory. This technology acceptance model, we also abbreviate this as TAM model, like TAM model. Like what this theory did, it helped explain how people adopt new technologies. So this is also a very important theory which I have taken into consideration in my research methodology. And finally, the last theory is the diffusion of innovation theory, which looks at how innovation spread across industries. The main objective were to understand the evolution of fintech credit scoring, examine the role of AI and machine learning, evaluate their impact on SME financing, and identify associated challenges. So this is the methodology. So to fulfill these objectives, I have applied these particular, like these theories, which are present in the research methodology. Moving on to the next slide. The next slide talks about the data preprocessing and AI or ML models. So one of the biggest differences between traditional lending and fintech lending is the type of data used. You should keep in mind this first. So instead of relying only on financial statements or credit reports, fintech platforms analyze information like such as digital payments, mobile transactions, utility bill records, e-commerce activities, and online business behavior. So this data is then processed using AI and ML models. So as you can see, this some of the commonly used models I have written over here. These are random forest, logistic regression, neural networks, and explainable AI. So these technologies help lenders make faster and more accurate credit decisions. So this is the slide which is related to data pre-processing. Now let's move on to the next slide, which talks about the result analysis. So I would like to say that this slide summarizes the key differences between traditional credit scoring and fintech-based credit scoring. So in this analysis, basically we are, as you can see, going to differentiate between the traditional method and the new method. So as you can see, the findings highlight three major benefits. The first benefit is AI models improve prediction accuracy. And second, alternative data allows more SMEs to qualify for credit. And the third one is the automation significantly reduces cost and processing time. So as you can see, everyone can see that this overall, this fintech performs much better than traditional systems in several important areas. So this is the final result and analysis which I have extracted from the literatures. Now moving on to the next slide. This slide discusses about basically the challenges and issues, the barriers which are related to the fintech. So as you can say that although fintech offers many advantages, it also comes with some challenges. The first challenge, as you can see, is cybersecurity. Since everything is digital, there is always a risk of hacking, data breaches, and identity theft. So this is also a major threat and a challenge. So, and talking about the next challenge is related to the ethical concerns. Like the second challenge is ethics. AI systems can sometimes produce biased outcomes or make decisions that are difficult to explain. This raises concerns about fairness and transparency. So this is the second challenge. Now moving on to the last challenge. The last challenge is regulation gaps. In many countries, regulations are still catching up with technological advancements, making compliance more complicated. Therefore, alongside innovations, strong governance and regulations are also necessary. So these are all the three challenges and issues which I have identified. Now moving on to the last slide, conclusion. Here you can see that to conclude, fintech credit scoring has changed the way these SMEs access finance. So instead of depending heavily on collateral and traditional credit histories, lenders can now use alternative data and advanced analytics to access risk more effectively. So you can say the study found that AI and ML improve credit assessment accuracy, increase financial inclusion, and reduce both cost and processing time. However, issues such as cyber security and ethical concerns and regulatory compliance must continue to be addressed. So even if there are issues and challenges, overall you can say the fintech has significant potential to create a more inclusive and efficient financial system for SMEs. So basically this is the conclusion, and these are all the references which I have taken. And thank you for providing me this wonderful opportunity. Thank you everyone.
Okay, so now I would like to invite Mr. Satyam Nikra to ask their questions.
Thank you. Yeah, it's a very good research. Actually, the basically what you mentioned in that whole research about like how ML is kind of transforming the fintech industry, like AI and ML. Uh, I've I've seen it like personally, witnessed it during my experience as well. We are using ML, so we are not just relying on FICO credit scores to determine the
Yes.
credit eligibility. But we are
Yes.
also using alternate data. Sorry.
Yes, I'm listening, sir. Please continue.
Okay. Yeah. So I just want to know, like, what are the some down, side effects of doing this? Like, is it possible that someone can fabricate this, their history or something, right? And AI picks it up, and although they are not eligible, and but some, like, because of this fabrication and now AI and then the machine learning models, they make it like eligible, that person.
So basically, it is this AI and ML only, which has become very important and necessary nowadays. As just now, as I told you, that it's a 21st century. So everything is getting digital, everything is getting modernized. So we have to move forward. We have to move further, like from traditional to new methods. So basically, fintech plays a very important role. As I told you, in terms of banking and lending, those people who are running SMEs. So it is very important term. I know it has many drawbacks. I understand it has many drawbacks. Everything has a drawbacks, but if you see the benefits, you can say benefits are much more than these drawbacks. So pros and cons are everywhere. So if we want to move further, since it's a 21st century and technology is upgrading day by day, so if we want to go ahead and move further, so we need to take the risk and we need to adopt the technologies. So according to me, although it has challenges, but it has also proved very beneficial, fintech, in terms of bankings and finance.
Got it. Thank you.
Okay. Thank you.
Thank you, Ankur. Thank you so much for sharing your
Thank you.
valuable research and insights with us. We truly appreciate your time and effort and dedication.
Thank you. Thank you.
Okay, for the next paper ID, I would like to invite Mr. Matthew M. Fernandez to present their paper ID GRM 1444, paper title Building a PMO from Scratch, a particular governance framework for organizations without project management maturity.
Thank you for the introduction. Can you guys see me okay? Let me just share screen. 1 second here. Okay, can you guys see my screen? Yeah?
Yes, yes.
Perfect. Welcome, everybody. Thank you for the opportunity to present. My name is Matthew Fernandez. Feel free to call me Matt. I am a project manager by background, different industries over the last 15 years, real estate development, construction, information technology, infrastructure, cloud operations, and even done some healthcare projects as well. So as we've seen the past couple of years, there's been a lot of evolution within organizations who is adopting a PMO kind of model framework. So wanted to just just kind of showcase some of the research that I've done and how the importance, right, of establishing a PMO for large organizations that's growing as well. So we'll get started. Quick overview. So we will go over a few of the PMO disciplines, 4 different elements that basically essentially defines what a PMO is, its structure, the organizational model, the different set of processes and workflows that the PMO designs and evolves within an organization, and also PMO governance, what sort of project controls, decision-making frameworks for leadership that allows enablement for teams and organizations to make executive level decisions, and also measuring project delivery with performance through KPI dashboard metrics as well. So what's a PMO, right? It's a project management office. It's basically a centralized unit within an organization. A small team can be a big team as well, depending on how big the initiatives are, how big are the programs that we provide. PMO provides different standards of project governance, processes, and practice all throughout the organization. So as organizations continue to grow, in my experience, I've started many different PMOs from smaller companies, even larger companies as well, who didn't have that kind of structure. So the PMO becomes the main central link, if you will, that kind of connects a variety of different departments within an organization to align with the organization's strategic values and execution as well. And right, the goal is to improve project delivery, processes that may not have been in place. We set that up, optimize existing resources that we have in place, working with different departments and supporting the strategic goals of the organization. So here, the literature review we've done, kind of highlighting some of the evidence that supports the value-driven model of PMOs within an organization. Looking into, I'm sure you guys have heard of PMI, the Project Management Institute, the largest organization for project management internationally, globally. Organizations with PMOs, they definitely demonstrate a higher project success rate, right, versus organizations that don't have any PMOs. So the research shows that having that unit helps improve, governance, maturity, execution, because you have that central unit that's focused on that one thing, on that one task in terms of execution, having administration, organization, processes, workflows established to help achieve alignment and execution for the organizational goals. Standard, project management practices, correlate with the success rates and also failure rates of project delivery. So an organization may have an objective, right? But how are you going to get that objective? How are we going to execute to accomplish that objective, that initiative? So not having a PMO, right? It's a higher failure rate, right? If you're not having a dedicated unit that is aligned and dedicated towards the execution of that initiative. Agile PMO, right? There's different types of, methodologies for project management, more traditional waterfall. The last couple of years, we've seen a lot of evolution for Agile, especially particularly in IT. So Agile helps to, it's more of an adaptive kind of framework to support, new innovation, new technology that's being built while still maintaining the controls necessary of what's existing as well. So the research sources here that we've collected will align with that as well. Reviewing our methodology through a variety of different structured reviews, different sort of PMO models, right? It all depends on, I think, the identity of the organization, how the organization operates. There is not one correct model. I think all the models are correct. It's a matter of choosing which frameworks align with the industry standards for that organization. What framework do we want to adopt? What framework do we want to adopt within our PMO model that is going to align with our execution, align with our delivery, align with our governance, align with our resource management, align with how we monitor and deliver these projects, and align with how we measure our success, right? Kaizen methodologies. What are things that we need to improve within our team, within our product delivery, right? Process of continuous improvement. So the framework here, was developed to kind of capture kind of these core, research areas for PMO, for the variety of different PMO delivery models that organizations can adopt. Right, as you're establishing PMO right from scratch, everything has to start with a foundation, right? So kind of phase one, if you will, kind of like planning and assessment, really looking inside the organization, kind of being a detective, understanding the terrain, right? Establishing organizational readiness, defining what the scope is, securing any sense of sponsorship or resources that's required to the establishment of that PMO. So just a couple of three things here that kind of sets the essential foundation, if you will, for a phase one kind of PMO establishment in that regard. Going into phase two, right? So once we jump into phase one and complete that, and then we have to see what are the core components, right? What are the core components that we want to implement within our PMO framework? So it works on developing what that framework is, what are the interconnected components. So all of these 4 components here, they're all kind of locked in and interconnected together. First components here for governments, which includes, the different policies, the procedures, what the SOPs are, what are the defined processes on how our projects are going to be approved and monitored, right? Within, having an intake system, like what does that process look like from a governance, standpoint, from a life cycle, right? From project initiation all the way to project completion. Second component here, resource management, ensuring we have the right people, right, to work on the right projects, having the right level of resources, measuring our head count, our knowledge gaps as well. What do we need to improve to apply the right individuals to assign them to the right projects at the right time? Project controls, scheduling, right? When are we going to start executing these projects? What is the schedule within our life cycle that is tied to our delivery initiative, towards the end? Like when is something realistic that we can accomplish in terms of our project schedule delivery, which involves risk management, right? Which involves, tracking and keeping a sense of assuredness that these projects are on track, responding to any project risks or any flags immediately with stakeholder and sponsor involvement. And then, measuring that with our reporting system and just providing that statistical real-time visibility to leadership, so that way they can help to make decisions based on real-time data within the project, help within the overall program, the portfolio within that organization of what's going on. How can we remove any barriers? How can we help execute these initiatives? What are some of the blockers that's going on? So having a sense of the reporting mechanism, I think is very important, I think, from all these 4, because it just gives that sense of visibility to leadership. And when the leadership has visibility, then that's when they can make decisions and execute. Results, right? Going, from phase 1 to phase 2, we want to measure exactly what are the benefits, right, in terms of establishing and having the PMO stood up within an organization and having it implemented all across, the variety of departments within the org on how, benefits can be measured. Through reporting, through metrics, right, we can measure the product success rate. This involves something, in governance and controls where we establish timelines, right? What is our product delivery success rate? Or did we deliver on time? Did we deliver late? We delivered under budget, right? We delivered under resource, right? Under any resource constraints, right? Resource utilization. So having that dedicated unit, an organized dedicated unit to kind of capture all these metrics and perform under these standards increases, right, the rate of project delivery for organizations as well, because the PMO, they're executing, they're measuring performance, they're applying their resources to execute the tasks that need to be done in their delivery model. They're managing risks, they're communicating, right, presenting visibility to leadership. So all of this is happening simultaneously, and this is really a value-driven delivery model. So a lot of times we're going to just say, like, why do we need a PMO? And like, these are the reasons why. This is our value driven delivery approach. This is why we are essentially a service, right? Think about it like a PMO. The organization is the customer, and the PMO, right, is the service provider, right? This is what we're delivering to align with your initiatives and your objectives. And I keep finding here that organizations with mature PMOs, they actually have a higher stakeholder satisfaction, higher project visibility, consistency with project execution. Organizations, right, that they invest within the PMO, they deliver, right? They actually, the PMO delivers that service. So organizations that have to invest money. We have to hire people. Let's establish a PMO. What is the benefit of doing that? The benefit is spread all across the organization and the completion of these deliverables that in the end generate depending on the project, can generate a lot of income for the organization as well. So looking ahead, right, maturity, establishing a well-built PMO, working through the evolution of that, establishing the foundation, the governance, the standardization, the framework, creates a long-term scalability of operational delivery within the organizations, structure, consistency, governance, and strategic growth of the execution of those initiatives that align with the organizational objectives. And as we see, I know we've been talking about a lot of AI. AI kind of presents that essential opportunity to advance, a lot of the PMO structures, helping project managers to execute a lot better, a lot faster, and even decide a lot better. So I know with AI, people think, oh, it'll AI is going to replace project managers. Not really. Project managers who actually use AI will replace the ones that are not using AI. So AI in this age of technology now is actually quite a benefit if it's implemented across within a PMO structure. And the different methodologies, the different frameworks, agile, setting up automated reporting to leadership, providing some sort of analytics, business analytics for clear visibility. And within this digital age of technology, right, giving structure and an execution path to organizations to continue to continuously improve on their advancements and technological opportunities for optimization all across the board. Some of the references here used to do the research. And that's it for this presentation here. Happy to take any questions if there's any.
Okay, Mr. Satyam Nikra, do you have any questions?
Yeah, just one question. I have quick question. So I think with AI, things are moving really fast, right? You mentioned in one of your presentations about agile methodology, right? Where we are doing the sprint planning for two weeks, right? So is there any new sort of this PMO or coming up considering recent advances in the entire software engineering industry?
Yeah, I mean, we've seen, I mean, if you look at it with the last 15 years, I think Agile has been adopted massively in terms of IT all across the board. Now with AI, we can kind of sense, I've seen it already kind of have that kind of Agile being automated, right? Having sprint board planning, PI planning, kind of like automated a little bit faster for engineers. You have now engineers that are not writing code. The AI is actually doing it for them, right? They're just there to kind of monitor and make sure. And maybe the AI is not perfect, right? So the engineers, data engineers, right? For example, they have to, they're like watching and seeing like, okay, I found this error, let me fix it. But AI now is actually, in terms of sprints, in terms of sprint delivery, it's actually advancing the way that the sprint methodology is now for IT delivery, for iterative, repetitive processes within project delivery. In terms where customers now, stakeholders are able to see results, I think, a lot faster in that lifecycle process where we want to show a deliverable increment, right, all throughout that process. AI. So AI, since it's been the last 4 or 5 years, I think, since people have adopted that, it's going to continue to, I think, further advance. It's advancing the data engineering work and advancing the deliverable increments, what we see for stakeholders.
All right. Thank you.
No, thank you. Thank you for the opportunity.
Yeah, so our award selection committee member is also available here. Okay, so Mr. Manohar, do you have any questions? Would you like to ask some questions to Mr. Matthew? Hello, Mr. Manohar, are you available? Hello, Mr. Manohar. I think he is not available right now. So you can continue, Mr. Mahek. Mrs. Mahek, you can continue.
Okay, Mr. Matthew, please proceed with presenting your second paper ID, that is GRM 1445, titled The Future of Project Leadership, What AI Means of PMOs in 2026 and Beyond.
Absolutely. Thank you so much for that. We're already talking about AI. So I did, first presentation was more the importance of the PMO. Now we're going to shift to more of what AI means for PMOs. You know, as of today, it's a little bit similar to what Mr. Nikra was talking about, and we're going to continue advancing that conversation. So let me just share screen here. Okay. Can you guys see my screen? All good?
Yes.
Yes.
Perfect. So no introduction needed. I think I introduced myself. So, right, continuing on to the conversation that led to that question, right? Artificial intelligence is transforming, like I literally just said this a minute ago, PMO across industries, AI-driven tools, improving planning, sprint delivery. Yeah, literally just what I just said. So I think now, like I said, project managers need to adapt and they need to adopt artificial intelligence to basically enhance PMO's capabilities, our functions, governance, planning, execution, literally everything of why should PMO exist. AI now is here to kind of optimize the existence of PMOs and how we contribute to the organization's value. So we'll go over this. These are some of the items here in terms of that abstract. Right, as mentioned, we're the backbone. PMOs are the backbone of an organization's project governance and execution. With the advancement of technology across a lot of different industries, a lot of industries, as we see, they're adopting AI within their workflows, right, within their execution models. And project leaders nowadays, we must. I think AI doesn't wait for nobody, right? So we either don't use it or we do. Those who use it, I think, are there at the forefront to see how AI is able to kind of help manage a lot of the delivery models in these environments effectively within the organization. So AI having predictive AI models, right? What can the AI predict in terms of analytics of our project outcomes, of our product success rates, those KPIs that I was talking about in the other presentation, right? How AI can help kind of measure those analytics, identify some of project delays, and see where we can potentially save any money from some cost overruns, like some gaps. Automation, right? Reporting, right? Which we talked about. Resource optimization to use coding algorithms, right? That example that I use, how data engineers are now not, years ago you would have to write the whole code. Now they're using AI to do it. So it's actually optimizing our existing resources that we have right now. And using that predictive analysis, using AI for that helps us to kind of detect risks a little bit early on. So then we can be more proactive in terms of our risk strategy, execution, implementation in that regard. So a little bit of the research here that we've done, just going over, right, same thing, PMI, a little bit of the existing research from the other one, having a sense of AI implemented PMO automation basically reduces a lot of the manual efforts from data engineers, the manual effort from project managers, a lot of the administration. You guys are in meetings right now, right? For example, right? We have AI, perfect example. How, you're in meetings, you're in your Zoom meetings, you're in your Microsoft Team meetings, you have Copilot, you have a meeting notes, right? That basically can send out an email automatically, highlighting all the action items, right? 10 years ago, when I, being a project manager, I would have to capture, right? You have to capture all your meeting notes and then email the action items and then assign it. Now we have artificial intelligence within these meetings, right? These high-level data-driven meetings where it'll identify who are the participants, right? Within that call, what their titles are. That involves as well you kind of training that AI so that they're able to identify. And you have meeting notes and action items already developed in seconds, right? So that reduces a lot of that administrative burden for someone like me, for a project manager, right? Reduces a lot of that burden from the data engineers, right? Who are not typing code. So a lot of the literature review research here shows that. And in terms of AI-driven leadership competencies, help with the overall improvement and implementation of, improving the overall operations, if you will, within the project management office framework for an organization. Methodological approach, a couple of the methodologies here that the research shows, some articles that we listed out, the importance, right? The analysis of how AI applications, applying that in project management, in comparison, right? Evaluating how it was before and how it is today, right? With that example that I just gave of action notes, right? And then kind of like, what are some of the trends? Like, what do we see now? AI is already changing stuff now. What do we see? How do we see it changing into the future, right? Which is kind of why I titled this, 2026 and beyond. We don't know, right? We can only guess and assume like how what's going to happen in the future. But I think we can only know what's going to happen in the future if we're in it today, if we're utilizing AI today, if we're in the mix, if you will. So that research methodology here applies to these four focus areas, right? Automation, predictive analysis, risk management, workforce transformation, resource optimization, similar to the previous presentation. So these are like the four core areas that AI kind of touches and affects, and the research methodology shows that within the resources here. Doing that analysis, there's been some conversation throughout the presentation here of machine learning, AI basically identifying, patterns, within a project lifecycle, doing predictive analysis, language processing, right? Automatic extraction of sort of data insights from project documents, right? You can, a good example, some specifications, right? If you're going to build out a server, what are the specs of that server that you have to build out, so you can do a cloud migration. AI can actually process that information and kind of even start drafting a sense of scope of what you have to do and how you have to plan that, right? You have your planning and your scheduling. What are the steps? Hey, how do I build this server? Here's the specifications for this server that I have to build. Here's the VM. Here's this. AI kind of collecting that data, analyzing that, and also kind of pulling out a sense of reporting that you can actually use and generate to provide for stakeholders as well. So a lot of there's been some topic of discussion here during this presentation, during other presentations too, but a lot of variety of good opportunistic machine learning models that essentially optimizes the value delivery that a project manager and a PMO does within an organization. So yeah, impact on AI, project leadership, we touched on this a little bit. The integration of AI into PMO operations and full optimization, transforming, right? Providing those statistical analysis for easy, quick, speed, fast delivery increments, just a lot quicker, a lot faster, and a lot more efficient with an AI-driven leadership approach. And just a quick comparison, right? What a traditional leadership approach does without AI versus like an AI-driven leadership, manual entry of stuff, more of a reactive management of issues, more emotional, where it's like AI-driven, it's like reduces significantly the manual burden, and more in terms of less of a reactive management approach of certain risks and issues. You have more of a statistical, data-driven machine learning analysis approach in terms of execution, which is pretty cool. Faster decisions, a lot more accuracy as well within AI, and overall 60% improvement of delivery of the delivery model for a PMO framework as well. Good impacts and results all across the board of planning, execution, resourcing, risk reporting. So just overall increase, like as as that data showed, overall 60% increase, overall efficiency all across the board for the organizations. So a more quicker, faster efficiency model allows for what? Allows for more value-driven delivery, allows for more opportunities. If projects are being delivered faster, more accurate, more efficient, that basically leaves room. If there's a 60% improvement, which is what the research shows, that gives us a 40% opportunity to do more. That gives us a 40% kind of space that like, hey, we have some room now. Let's kind of do more other stuff. What else can we do? What more can we invest in? If we're delivering on projects faster, if we're delivering on projects that are going to generate income for the organization is spending money to then make money a lot faster. And if they're making money a lot faster, that gives us a 40% more space to then continue to execute a lot more. So positive, within that domain, positive results within analysis of the impact of AI in all of these areas in project delivery within an organization here. So looking into the future, right? Not everybody, right, is using AI, right? We see some people are more a little bit more resistance, right? Even in some trainings that I've done within my organization, right? We had to implement a policy that yes, you can use AI. Here's how to do it, right? Develop an SOP. So which involves a lot of the change management. How it is more of a people management situation that presents some challenges. Some people are maybe a little bit more resistant, but as adopters of artificial intelligence, we have to incentivize the benefit of using AI so that way it can decrease that employee resistance. Implementation costs, right? It's not cheap. So when you're investing in artificial intelligence, yeah, you're going to get a faster, delivery model, but it's also it can fluctuate, right? The different kind of cost metrics. And integrating AI within your organization. Data privacy, right? As AI continues to evolve, you have organizations, you have government organizations, regulators, right? In terms of data privacy concerns that have to be, abide by compliance as well. Sensitive information, PII, for example, personal identifiable information. So as long, just some of the challenges to adopting AI, but as long as we follow a compliance-driven governance model, no issue there into the future. And skills, right? When I started using AI, I didn't know in the beginning, right? And then you start using it and you kind of get familiar. So project managers, they require some new sense of learning, right? In AI, you can't just use the AI off the bat. You have to see, you have to kind of train the AI. You have to kind of mold the AI, and that requires some sort of training and skills to be able to adopt that as well. Going into the future, right, you have some PMOs that are autonomous, that are self-managing, very similar to kind of Scrum and Agile. You have a self-managing kind of team, right, for data engineers. Same model here, right, for AI. You have autonomous PMOs that are just kind of monitoring, right? You kind of let the AI kind of keep going and then execute, but you're monitoring that execution. You're actually executing yourself, but also by monitoring in a self-managing capacity. Decision support systems, helping to identify what is the decision path that we should make here based on the data. What's the recommendation here based on the data that we're providing, right? To help to kind of identify the path forward for some complex decisions. Digital product assistance. I'm using that right now in one of my previous roles. Having a sort of a dedicated AI assistant to help set up reminders for me, set up some email automations that I need to do. So that gives us a lot of opportunity, and even an AI assistant that can help kind of build out a dashboard metric at the end of every month for reporting that I already have set up. So it's actually pretty cool once you kind of learn and see what AI can do to kind of help, alleviate me of my time, which then I can go out and do other value-driven things as well. And human AI collaboration models where, right, the thing is more, humans, we react because we're emotional. AI is more, right, strategic, more, less emotion, right? So it's like, are we reacting to the right decision here by doing this based on this, or are we strategizing? Like, what does the AI think I should do? Which I think gives us that opportunity for the future in terms of more of a human and AI collaboration. Not necessarily saying that we have to follow exactly what the AI says, but what's the recommendation here? What are some of the human elements that I can incorporate within the artificial intelligence decision-making framework that, can produce some positive, optimal outcomes through the mix of a lot of this complexity that we may be facing. So towards the end here, as we see, a lot of big topic of discussion here, right? AI is, shaping everything, right? A lot of the examples that you guys talked about, within our project leadership, different functions all across the board, all across governance and organization. So my taking me being more at the forefront, I think those of us who haven't used AI before, just my recommendation, just kind of embrace it, jump in the deep end of the pool. Don't tip your toe within the shallow of the water. I think just kind of embrace it. We're in this, it's 2026. And I think in order to keep up with the market, we really need to adapt and what we see within the future. And if you think about it from a technological standpoint, every 10 years, and I'll end it with this, every 10 years, there is something new. I'm 37 years old, right? So I remember how it was within the 90s. I remember my dad's beeper. I remember when the internet came out, right, in 1995, 1996, right, AOL and dial-up. I remember that. I was a child, but I remember my mom, talking on the phone, right, and then the cord connecting to the internet, that everybody who would call your house, the line would be busy, right? Every 10 years, something happens. What happens, after internet was invented in 1995, 96? 10 years later, then you had Facebook, right? You had MySpace. 10 years later, 2006. What happened 10 years after 2006? Then you have Uber, and then what happened after Uber 10 years later? Now we have AI, right? We're in the 2020s now. So if you look at it from a cycle, every 10 years, there is a new technological advancement that just changes the way we live. And it all started in 1995, 1996. And now we're in 2026. So future work, just future considerations, it makes me curious now, what's going to happen within the next 10 years? And I think we'll know that only by being in the forefront of what's happening right now today, which is artificial intelligence. With that said, I'll end my presentation, and I'm all good. Thank you.
Okay, thank you, Matthew. Now, Mr. Satyam and Mr. Manohar, do you have any questions?
Not for me. Thank you.
Okay, and Mr. Manohar? Okay,
So Mr. Nilesh is available for
Okay,
keynote
okay.
speaker.
Okay, so now we are delighted to invite our respected keynote speaker, Mr. Nilesh Bandarwar, to deliver keynote address.
Hi, good evening, good afternoon, good morning all. It's a cross geography. Let me share my screen. Let me know if folks able to see my screen. Please confirm if you are able to see my screen.
Yes, it is visible.
Yeah, so good morning, good afternoon, good evening all. So myself Nilesh Bhandarwar. So I'm a senior software engineer working with Microsoft, and thanks for giving me this opportunity today. And thanks everyone for joining this keynote. So today, actually, my keynote topic will be the rise of agentic AI, and I'm going to discuss in the three domains like cloud, cybersecurity, and software development. So this is like a very it's like a larger now, as we know, as we move into the AI evolution. Now it's larger than just a AI feature or new productivity tool. So we are now moving from AI systems that like reactive, like primarily responding to us, towards more like automated AI system where we can actually participate, that can participate to work with us. That means the systems can reason, they can have reasoning over the goal, they can plan, they can actually create the skill, they can actually execute the goals, and they are actually in very much in automation, automated in making the decision. Even they can observe, they can verify the results, and they can interact with software tools, monitor the progress, escalate it to the human, escalate it when it required, and also we can have human feedback loop to make it more trustworthy and safe. So this today's topic is more on like the rise of agentic AI. The focus today is deliberately I kept it practical. So we will look at like how AI is transforming the three domains I discussed, like cloud, cyber security, and software development. So executive summary. So agentic AI represents the operating model change, like what earlier system was. If you see, what like 3 years back, when when ChatGPT was uh, published, or ChatGPT came into the picture. So the paradigm was more like on what can model tell me, and now with agentic system, it will be more like what can the safe system do the safely. So the paradigm is shifting from asking system, hey, what model can actually supposed to do, from the capacity of model is now to how the agency system are safe, how the system can do the work safely for me and it automated way. So safety is the word where it is responsible, and apart from safety, there is another word that is responsible. So agents are valuable because they are pursue goal, use tools, and coordinate the work. But at the time, they are risky because they are automated. So somewhere we have to have some governance and or control over those automations. So there is opportunity and responsibility which is inseparable when it's a rise of agentic AI. So in cloud operation, actually, if we see the in agentic AI, so we are moving away from more like a reactive dashboard alerting system where we have like some defined set of rules, set of alerting. Now it's more like an adaptive or automated orchestration where agent can actually go and read your telemetry. They can create incident, they can run books, and they can cause signal, they can even mitigate the issues. So this is where now agentic AI is moving. And in cybersecurity, that means it can analyze, it triage the alerts, it can summarize the evidence, it can investigate the events, and it can even draft the response action or create even RCAs. So in software engineering, as we know, it is exploding. So it means we can have agents. So one engineer, it's like the paradigm that I'm seeing in my company, like it's supposed to be one engineer is now like a manager, and one engineer is now running the teams of 2 3 AI agents, which will be independently doing development, requirement gathering, designing, development, testing, then deploy the code. So everything is 2 3 agents working with the one engineer. So more important, I want to call here, so AI is not like a replacement for agent. That's what I see. It's more like an co-worker for software engineers, or even any field like cloud operations, cybersecurity, which can increase to multiply our productivity. So let me begin with the central hook for this keynote. So for a decade, we ask in the AI, whether AI can understand us or not. But now the question is changing. The question now is whether AI system can act with us, for us, or within the limit we can trust. So this is the whole point. Like we have the anomaly of complete automation with agentic AI, but how we make this system more trustable, safety, and also act with responsibility. Because we have seen the examples, AI with this agentic AI, they can go very wild. I think the recent example with some of the travel company where with no proper authentication and authorization, it actually deleted the whole database of the system, and it deleted the 3 years of data of customers. So that is where the trust, safety, and all this come. So now the question is from where we are moving from chatbot can answer a question to the agent who can potentially open a ticket, that can curate database, modify the infrastructure, run a test suite, call an API. So that's how actually we are moving. So if you see, I have actually pointed out 3 questions where we moved from. So initially, like, what can model tell me? So we are moving to what actually agent can safely do for us. How accurate the answer? It's now to how control the action is. Now it's moving from what task can be associated to which workflow can be orchestrated. So these are the actually shifting in the priorities with the agentic AI. So we are no more longer on the responsive side, where we actually dealing with the react and response. Now we are moving into the automated and automation, but control automation. That is actually theme of this. This question actually, it's like what makes AI agentic? So AI agentic, so what actually difference from the traditional chatbot or traditional this LLMs to AI agentic? So AI agentic, if you ask, the key distinction is that agent is actually oriented towards goal. It's focused. It has been designed for addressing the specific goal. Just not a response. It has a standard generative AI assistant that may produce the code, that may produce the text or an explanation also. And in agentic system goes further. So from generative AI, that is the difference. The agentic system that can go, it can break the goals into the steps, it can plan, it can choose tools, it has all autonomy. We have now multiple protocols in the picture like MCP, ACP, A2A. So it has the autonomy to go and talk with the different tools. It can monitor the outcome, it can adjust the behavior, it can learn from the mistakes. So these are like automation without any human interaction. So that does not mean human has to be involved. Yeah, because we has as a human, we need to involve in this as part of judgment. So AI agentics work well, and it works safely and it scale when there is some judgment from the human. So we at this point we cannot completely rely on agentic AI. So it is a good tool, it can scale, but it always requires some human feedback in the loop. Some companies are really working on even removing the human feedback, but I still believe human judgment will always play important role in the future also. So the capability in the goal orientation, then it's also a planning, tool usage, monitoring, adoption. Tool use is the especially important because it actually makes the agentic AI more powerful, because it allows agentic like any AI agents to connect with the external world like APIs, database, maybe any service. That makes the agentic AI more dynamic. Because if you remember in 2022 when ChatGPT was launched, it has a limited model. Whenever you ask some questions beyond 2023, it has a response, hey, I have been trained only till 2023, because at that time there was no tooling or there was no this external capability was there. But in 24, there was an invention where they can actually, the LLMs can make the external calls, web search, and based on that they can actually provide you real-time data or real-time search. Now, beyond automation and copilots, so it is useful to separate agentic AI from the two ideas we already know well. That is one, traditional automation and copilots. So traditional automation is the area before AI evolution where we have predefined rules. We have some automation that writing some scripts, some automated software, but we all know the limitations. When there is a new requirement, you have to change your code. You have to keep on adding some if-else condition, and that's like system becomes more brittle. Uh, and so those system works well when the process is stable. We have deterministic input, deterministic output, so that works well. But when it's become a more and more dynamic, those systems are maintaining it very challenging. I have seen that one. With generative AI assistant, it makes life easy. Yeah, it suggests some code suggestions, it suggests autocomplete and all that, more the code suggestion. But again, it's more on reactive side. Now the agentic AI, that is the one which is a game changer now. So in agentic AI, you have to just define your agent with specific goal, and based on that it can plan, it can actually create the tools, it can use the tools dynamically, it can act, it can monitor, and it can escalate towards the goal. And as I said, the important thing, it can learn from their own mistakes without being any human interaction, and it actually reacts to a dynamic inputs. So that is the important thing. You don't have to, like, if there is something new condition come, you don't need to worry about adding the new conditions. All the agents are now smart enough to adopt those change and learn from that. So if I had to give example, like let's say there is a code fix suggesting a fix for a failing deployment, or agent might go and inspect the logs, it compare the recent commits, then propose a rollback, maybe propose a solution, or even open a rollback. So in our company, in my project, what we are doing, one example we have to give. So we created a agentic system which actually identifies all the security vulnerabilities in the pull request itself, and even it creates the fixes for those vulnerabilities in a separate pair in automated way. So the goal was shift left pattern, so that no bad code or security vulnerable code will go into the production. So that's one of the example. The question is now, why the agentic AI is now the need and more than anyone else? Because and why the shift is happening. So answer is like, yeah, AI models have improved. The deeper reason is that model digital environment have become too complex. If you see, like, we have now petabytes of data, so many of demands, so many of new systems are coming. Cloud platform, if you see, it contains a lot of distributed services, elastic infrastructure, changing configuration. So handling this before AI, it was like all manual effort where people are actually working and configuring these changes, monitoring the traffic, making sure everything is working fine. And then handling this with the manual, it become very, very complex. And as we are moving, we are getting a huge amount of data every day, and it's growing and growing in exponential way. So that becomes a very complex job for the when it comes with the manual control. Even the same issue with the cyber security. The cybersecurity threats are so evolving, the hackers are evolving day by day, and they're coming with the new ideas. So that also becomes very with the rule based system, it is very challenging to handle that. So result the result is like a coordination problem. So the problem with is like coordination when it comes with the manual. So organizations are not short of tools, they have like there are plenty of, but then the problem is we are all are overwhelmed. So that's where agentic AI actually becomes important, because it offers a way to connect perception, it reasons on the action, it works in automated way, it scales a lot, and it has a dynamic way to adopt the systems. So it can actually well correlate the signals from your log, it can hypothesis, recommend the next steps, evaluate the appropriate actions, and then escalate the exceptions also. So this does not eliminate the need of expert, as I said, it still requires a human effort, human judgment. So that's a part. So key goal here is, yeah, we have to move towards agentic AI. Agentic AI is changing the world, but human judgment is still required. Yeah, even that with autonomous and autonomy, we still require a human intervention. That makes the system more effective, because trust and responsibility is the and safety. These are the three important things when we work with the agentic AI solution. Another example, like with the cloud, as I said, we will be discussing with the three domains. So let's start with the cloud platform. The cloud is a natural environment for agentic AI, because cloud operations already depends on a lot of complexity, like policies, API, automation, a lot of feedback loops, scalability. And that means today many teams still operate in a recent mode, like alert fires, engineer open the dashboard, then check the logs, check the recent deployment, searches runbook, decides. It's like run some TSG. But agentic system that can compass that workflow by connecting observability data directly from the diagnosis, govern remediation. It can take all this manual load on them, and it can do it in a very efficient way. So if I had to give the example in the self-optimizing cloud model, so agents can correlate log, they can trace matrices, they can traces, they can read the trace, they can read the matrices, they can read the deployment events, even they do configuration changes with the right amount of accessibility and security. They can even form the root cause hypothesis. They can even root cause hypothesis is like nothing but the root cause analysis. They can also identify dependencies. They can also provide the cost signals, cost optimization, and they also support the resource optimization by identifying over provision infrastructure and all. So this does not mean that cloud runs itself without human oversight. So I'm still emphasizing on, yeah, it does a lot of automation, but still human judgment and human oversight is required. So that is the important thing. So as you can see in the side, we have observe, learn, and then optimize, and still there is a human approval is required always to verify. So agentic AI, what is the agentic cloud control loop? So this slide actually shows the architecture that makes the agentic cloud operational credible. So if you look into the size, the pattern is like not the winning pattern. If I had to say, it's not like a single and constant super agent. Instead, it is a control loop connecting telemetry. So it has a telemetry context, then it has a policy, action, verification, and learning. So telemetry provides obviously the raw evidences, the raw logs, traces, events, cost and configuration drift, and then context gives the evidence by meaning adding the architecture maps, dependencies, ownership, recent changes, or recent history. So and policy is the like a critical control layer. So it defines what agent is allowed to change and not, and approval and when the approval is required, and what's the blast radius is acceptable. So that is where it's like a very controlled governed action. So this is like where we do like telemetry, context, then learning, action, and then verify. So this is like a control loop. So in that loop, we have to like operate on the cloud in order to make sure we using the agentic AI with the safety and responsibility, with always have the human interaction whenever it's required. In cybersecurity, if I will move to cybersecurity. So security operations are center. Security is the most important thing in any systems in the world, because if your security is compromised, no matter how well designed your systems are. So security operations centers are under constant pressure, and right so, because they have to deal with the high alert volume, fragmented evidence, always have to look out for some bad actors, high alert volume, because one security breach can cause billions of dollars of loss, and also loss in the company reputation. So how agentic AI can help here? By it can take the repetitive parts of triaging or administration while leaving the ambiguous and high impact or policy sensitive decision to human analysis. So it will be taking a lot of load from what are the repetitive tasks from humans it can do for us, and then based on the result produced by that, human can provide the analysis on those that cybersecurity task or any threat analysis and all. So objective again is not to remove the analyst. The objective is to give analyst a better evidence and faster context than making the clear decision pass. So that's like overall productivity gain. And then in agentic SOS, the agents can ingest signals from the identity system, endpoints, network, security tools. They can also summarize what happened. Also, they can identify what assets are affected, build a timeline around that, prioritize the incidents. They can even translate the malware or suspicious code behavior into a plain, explainable language. So that was the very powerful, like rather than going human being and interpreting those, agent can do all these things for you. So human gates still remain essential. If an action could disrupt the business operations, affect users, or change access by privileges, it should require approval and traceability. So this all things are good. And again, I'm stressing more on that. That's from my experience. Yeah, you need a very responsible AI. You want a responsible AI. That only makes the AI very valuable rather than the automation. Automation is an important part, no doubt, but when it has a responsible and safety behavior along with the trust, that actually makes the agentic AI more powerful. Now, security risk, which actually moves now from output to action. What does it mean? So with the rise of AI agents, it also changes this risk model. With traditional generative AI, the main concern was often the output risk because it can be hallucinating, it can be giving the wrong answers and now. But now agentic system, that is still important, but no longer it's enough. It's not only that risk. That risk responds now to the action risk, like whether agent is doing the correct job, whether what access agent have, whether they have the correct set of access, what tools it can call, and what credential it can use. So these are the things where we require a human judgment, and we have to be like, who is like designing the agent, they have to be very careful on that. And can it read sensitive data? Can it accidentally escalate the privileges? So all these questions we need to be, these are the risks we need to be taken care or we have to consider when we are designing the agentic AI. And that is why governance control is the important thing. And in our company also, we do, whenever we develop an agentic system, any agentic system or agentic feature, there is always a governance committee who actually goes through all the operation readiness, prerequisite and all, and based on that only it gives the approval. And even when the system is in place for any output or any sensitive information or output, there is always a governance control before it finalizes on that output. Yeah, software engineering, as most of them know, it become now agent orchestrated. So from our experience or my experience, I can tell you like the landscape for software engineering is changing. It's no more longer like you write how many lines of code and all. It's not no longer required. It's now, as a software engineer, you have to work as a manager, software engineering manager, where you have 3, 4, 2, 3 multiple agents you are running. They are doing the multiple parallel tasks, and you will be the man. You will be the one who's managing the engineer. So AI will. It's not like AI will replace software engineer, but yes, AI can replace the engineer who is not using the AI. So software engineer who are using the AI, who are using the agentic AI in a way to gain their productivity to the X100 or X times, they will always be in demand. And more you actually adopt to these changes, and more and more that you like make sure you are actually become AI evangelist by adopting the all this new learning and all, and more how you can actually design the agents, how you create your own team of agents with responsibility, safety, and trust. That's actually will be the software engineering. So as I said, it will be more like agent orchestrated. Developer productivity, yeah, obviously a developer productivity is high. If you can see, it's not about the lines of code. So if you see the new changes, like what's the business value you are delivering, that is now impactful. How your code or how the solution you are actually giving with the help of agentic AI, now how it helpful for the business, how it actually making the business more productive, how you are actually doing more for less, and how many workflows you are actually doing, and how actually they are useful for the business. So these are the actually developer productivity will like change. So it's the old where it will be judged on how many lines of code you would wrote, what your individual output, what was the local task completion, how the manual rework you did. But now it's all with agentic AI, it's more actually shifted towards business. The problem is solved, the speed you actually, the what speed, but without along with speed, how secure, trustworthy, and safe your solution is. I will be just quickly wrapping up. And then value comes, as I said, human agents, yeah, human system, human feedback and human judgment is always the important part of this agentic AI. That must be and should be there always. And that is one of the important fields. So human working with the AI agents, that actually makes the system like near to perfect. Governance must be, yeah, so there should be always governance. So it's depend on every use case and every company case, but agentic AI should have some governance. So traditional governance often actually focus on policies, reviews, and documentation, and that is still necessary. But with agentic system, it requires some more because agents can act actually during live workflows. So governance must be operate while agent is working. So it also changing the landscape for governance, like, so it should define the scope, identity, permission, tool access, approval, threshold, what kind of privilege we can give. So these are just I explained just before. So that's where the governance shift is also changing along with this AI agentic rise. Closing section. Yeah, this is the one of the important thing. So agentic AI will not replace the human. That's again I'm repeating on that, but it requires human judgment. It will raise the value of human judgment by surrounding it with the system. So that means it can observe more, reason faster, act carefully, and learn continuously. The future of work of AI is not simply assisting or AI assisted work. It will be more like coordinated human plus agent system. Like it will be that, as I said, it will be like more like a co-worker. So it will help us to increase our capability, productivity, but we have to make sure it also have trust and accountability. And organizations that succeed will not those who give the agents unlimited freedom, but the organization that will have right amount of governance and human control. So I will end this slide and I'm open for any question and answer. Thank you.
Okay, we now have Mr. Rupesh Shirke from the advisory committee with us. Mr. Rupesh, please go ahead with your questions.
Hi, thank you. Hi, Nilesh. It was a really wonderful presentation. And my only question is, I came from the cybersecurity background. I wanted to check, right, when we implement agenting AI or any tools which is automated, how we usually go ahead and consider the security here, right? When we differentiate with the legitimate user as a person and the actual bot and the threat vector, which is could be someone else from outside the organization, right? So how we can differentiate in this whole implementation? Thank you.
Yeah, so we actually, that's where actually I think we have proper skills defined when we define the agentic AI. We also have like human in the feedback loop, and also the AI. We should have like so when we build a agentic AI, it's like a team of AI, a team of agents where each agents will be doing their own specific task. So coming back to your question, like about outside vectors or bot and all, I think those actions somewhere has been. So when we are doing, one agent might be logging those actions and all, and one agent might be monitoring on that. Hey, whether this is something anomaly, whether this something looks very suspicious traffic and all, it may delegate to some other agent, and that agent may reasoning over that, and it may go to some human as an alert and all. So that is where actually in our company, that's how we are actually doing all these things and identifying if any bad actor or bad traffic, or even someone is trying to get into our system or like trying to hack and all. Yeah.
Okay, cool. Thank you.
Yeah, so Mr. Deepak is also available. He is also an advisory committee member. He want to ask some questions to Mr. Nilesh. Am I right?
Okay, so yeah, so I have a question like with this from the software engineering perspective, right? Recently, I was writing one code where I was just giving a very simple task to the agent, right? Just to make a small changes. I was just asking, okay, just do a small piece, and the way it was working, right? It just removed some piece of code which was not required to be removed, right? So my ask is, how do we, what best practice we should follow to use these agents in effective way? Because in a live, right, if we have a projects where we have a tons of code, tons of lines, and if we are making any changes, right, and I know human touch is required, we always see, but the idea, what the question I'm asking is more on, because we know we are monitoring, we are seeing this issue is there, but we end up spending 4 hours fixing the small fix.
Yeah.
You got the point, right? Working reiteratively. You keep asking, okay, I'm asking this, you are doing this, right? So what best practice we should follow?
Yeah, that is actually a very good question. So what we follow, and I actually face the same issue. Sometimes AI just try to do agenting, even agents try to do the things which are not been in the scope. So we try to limit. So in that case, best we do, we scope the agent with the specific goals, specific kill set, and we specifically put some guardrails on that. Hey, this is your scope, and you are not supposed to do anything. So in my case, I give example. Hey, I have the feature. Let's say I have feature XYZ. So okay, we just give very specific. Hey, I have this feature. You have to just focus on that. And then I made add some additional thing. Hey, I want this to be a scalable. I want also to be memory optimized and all. But make sure you are actually not touching the other part of the code, or you are not doing unrelated changes. And if you are making it, provide some comments in the pull request why you are doing that, so that at least if it get accidentally, when I reviewing the PR, I will get, hey, so I it happened with me. So in the recent one of the change, I give agent, hey, do this, but I explicitly ask if you are doing some actions, then at least add comments why you are doing it, or add comments in the code. So in that way, we got some of the actions. Hey, this was not required, and we then when we iterate it, it says, oh yeah, I made a mistake. So this is actually, that's what I said, like agents. But as more and more we iterate, it becomes a perfect. But more you keep your agent specific with the specific goal, it will not iterate. But if you give multiple things to the one agent, hey, do this, it might have the chances, it might get confused, and it try to do a things which is not supposed to do. So my advice here, the best practice is to limit the agent scope, to have the specific skills, and always have the guardrails with the system, so that it will save your time. But as we start in the any new feature, you might, as you might have to do iterate few more times till the time your agent become more and more mature. But as it become mature, it will be like less work on the side. So it's an initial investment, but it will become more and more stable and scalable over the time.
Thank you. Got it.
Yes, I think Mr. Ashish also wants to ask some questions.
Yeah, actually, most of the question is asked, and but my
Yes.
basic question is, now we could see in Nilesh, like you are developing a lot of agentic AI and a lot of agents. So we are also working and we are also production live in that. But the main challenge we are facing, the tokens, the usage of tokens between the agent and the sub agent, that's killing our cost. So I would
Yeah.
like to understand like how you're handling that token cost, because as per our side, how we work, we talk multi-agents with multi uh, types of vendors. Like we talk multi-agent, like Claude is talking to Gemini, whether you are correct or
Yeah.
not, and then cross-check. So we have spinned up this kind of API and enablement we have done for a lot of people. So what the main pain area is coming as a part of Center of Excellence, we work as a Center of Excellence. We cross our budget, like what we planned for this month, and it gets crossed quickly. So how you are handling in your use case?
So to be honest, this is a global problem.
Exactly.
And I think this will be the next area where researchers will be have to invest, like how to optimize token. So what we did in our company, at least I know in our team, so architect from our team, he actually suggested us to check the chat debug. So at least with the GitHub Copilot, we can see the debug message, and the debug messages can tell you how much your context window used where. And based on that, you can actually optimize your skills and your prompts. Skills and instruction is nothing but the one just the structure prompts, right? So you can optimize on it so that AI will not add their own context. So what generally the cloud has the problem, it is a best coding model, no doubt about it, but it adds a lot of garbage to your context, and it's your token window. So more you understand behind the scene, like what specific to your messages and prompt, like what they are using. So chat debug is the one thing which we found very useful for us, and that actually tell us why this is getting so much. So we actually optimize our prompt and LLM to be more specific, so that it will not eat more token. But still, that still is a problem for us. And if you heard about it, Microsoft might be canceling on the cloud
Exactly.
licensing and coming up with their own models. So that's a global problem, to be honest. And there is it is like evolving. There is no like perfect solution for that. It's a evolving space. But I see like more and more research will come, and who will solve this problem. I think that will be very valuable, because this is the very hard problem to solve at this stage. It
Exactly.
just, you have to keep on finding the different patterns. Yeah.
Yeah. Thanks. Makes sense. Thank you.
Yep.
Okay. Thank you, Mr. Nilesh Bhandarwar, for sharing your valuable insights with us. We truly appreciate your excellent keynote address and meaningful contribution to this conference, and we grateful for your time and expertise.
Yeah, thank you. Thanks a lot. And thanks again for giving me the opportunity. So glad to share my knowledge. Yeah, thank you.
Okay, so now let us move forward to the next paper presentation. For the next presentation, I would like to warmly invite Mr. Varun Rajak to present his research work, paper ID GRM 1467, titled Machine Learning Driven Automated Quality Inspection of Steel Plates in Industrial Production Lines.
Yeah, I'm there. Can you hear me clearly?
Yeah, sure.
Okay, I'm sharing screen my first. Okay, is it visible here?
Yes, it is visible. Mr. Varun, can you please open your camera?
Actually, ma'am, my camera is blocked, so they're not working.
Okay, no problem. Please continue.
Okay. Okay, so basically our title is Machine Learning Driven Automated Quality Inspection of Steel Plates in Industrial Production Line. So basically this project is focusing on artificial intelligence and deep learning techniques to automate, detect defects in steel plates. So improving quality controls, reducing manual efforts and increasing industrial productivity. So here's the abstract section, so in which describe the steel plates are widely used in industrial, such as the construction, automobiles, manufacturing, pipelines, and heavy machineries. So every small defect on steel surface can reduce the product quality and leads to a safety issue. So the traditional defects inspection is performed manually, which is time consuming, expensive, and prone to human error. So our problem is solve this hybrid CNN bilastium deep learning models using fault steel plates in the data set. So after the preprocessing, balance the data sets, the training models achieved 99.7% accuracy. So this result is demonstrated the effectiveness of AI-based automated inspection of system. So here the introduction section in which describe why steel inspection demand automation. So steel is the one of the most important material used in the modern industries. So however, during manufacturing, defects can occur because of the temperature variance, machinery stress, equipment instability, even though production process error. So manual inspection faces several challenges like working fatigue, inconsistent results, higher labor cost, so slow inspection speed. So therefore, the industry require automated system capable of performing the real-time inspection. So our process, machine learning and deep learning offer the powerful solution to identify defects quickly and accurate without the human intervention. So here's the several researchers has worked on steel defect detection. So some important studies included like RTDETR, it's achieving 92. That's the MAP 50. So there are a lot of research out there. So the existing approach still faces challenges like difficult handling complex feature extraction, higher computational cost. It may be a limited real-time industry deployment. So our work addresses these issues through our hybrid CNN and Ballastium architecture. So here's the proposed flow. First, the data collection, then we pre-process the data set, then balancing, then scaling, and the hybrid model applied. So in this section, data collection, we are using the fault state pair dataset containing the sample 1941 and 34 attributes. So it's have a different 7 tag classes. So after the pre-processing part, we are cleaning and normalization we are performed, like removing the null values and duplicates and so on. After this, we are performing like a smooth for data balancing because data is not biased of this majority classes. So that's we are applying smooth balancing. Then after feature scaling, all features are normalized in a single range. So then after going to the CNN Balastium model, these process data is feed into the hybrid deep learning models for classify. So these systematic pipeline ensure the reliable and accurate defect predictions. So here's the hybrid architecture. Firstly, we are using like CNN spatial feature extraction. It is spatial and is the best for feature extraction model, conventional and pooling layer. Capture the texture, edges and local structure pattern across 34 input attributes. So like CNN learns for surface texture patterns, detect characteristic and hidden structure of this data. The another model is Bilastium. It combines of this both the temporal contextual learning. The feature extraction by CNN, it passed to the Bilastium model. So Bilastium process informed in forward direction to the backward direction. So unlike the normal LSTM is learned from both past and future, the context. So the Bilastium by using like steel defects can often influence by relationship among the multiple attributes. So Bilastium capture these dependencies and improve classification performance. So in which use like there are parameter of this architecture like learning rate. The best size is the epochs for running this model iteration as the optimizer and activation function. So here is the preparation, pre-processing data for optimal performance. There's the cleaning in which using like machine value, duplicates, and noise reduction for ensure data integrity. Like there's the benefits for this, like faster training, better convergence, and reduce to impact of large values. Then after going to the section, min-max scaler, they scale the all attributes in 0 to 1, reducing outliers, influence the accelerate convergence. The next technique is mode balancing. The mode generate the synthetic samples of the minority classes. They reduce biased, improve model fairness. So after in the end, the stratify splitting. So training and testing data that maintain the same class distributed. This ensures the reliable evaluation. So here's the experimental result and performance in which they achieve like 99.7% accuracy. That model how it's best or not. That the comparative compared to traditional machine learning models, like 8% of improvement over the KNN. So though 9.56% improve the random forest model and the nearest perfect confusion matrix across all the 7 data classes. So these results confirm that our model generalize well and experience and minimal overfitting. So in the end, the impact of this road ahead is the conclusion section. So basically, this research is successfully developed a CNN Balastium model hybrid for steel plates defect detection. So this is the model is outperforming the traditional method, reduce the dependency on manual inspection of this human. So it supports the real-time quality monitoring. So in the future time, we can deploy this system as real industry production line, integration with PLC and edge devices. So we can use in the future, explore advantage architecture such as ResNet, EfficientNet, and attention-based model. So these improvements can make the system even faster and more efficient. So here's the references. Thank you for the attention. That's all, everyone.
Okay. If anyone has question, please go ahead.
Yeah, I have just a quick one. Why did you use the hybrid CNN plus that BIL STM model instead of just using CNN or only traditional machine learning models?
Okay, that's a good question. Because in which use like hybrid model, because it contain the different special features of the CNN and the BILSTM. But it's if we use like single model like CNN, so that's not a capture a particular monitoring of this real time system, because the CNN is based on it's just for extract the features, but the BILSTM combines the remember the relationship will be the past to future and future to past. So that's we combining the whole process architecture to make efficient.
Okay. And also, how much data you have used here to determine this accuracy? What is the size of
Yeah.
data set?
In this section, we are using like 1,914 dataset samples in this section.
And these are images.
Yeah.
Okay. Got it. Thank you.
Hey, Varun, I have one
Thank you.
question.
Yeah, sure.
So I came from industrial control system security. So I just wanted to know, right, because this manufacturing plant, usually they are very susceptible for the outsiders, right? So how the security is maintained in this machine learning models, and how we can verify that the security is maintained properly?
Yeah. So securing data storage, like in which use like stores inspection data encryption databases. So restricted unauthorized access using unauthorized mechanism. Like we are using like CNN Balestier model. They architecture in inspection the real-time systems. So all allow only the authorized operation and the administrator to the allow the system. So the continuously retain the update the CNN Balestier model with the new data. So it protect the model from outdated prediction from the performance degradation. In the other word, like protect industry devices from the cyber attacks.
Okay.
So security is the maintenance for encryption data storage.
Right. Okay. Thank you.
Okay. Thank you.
Okay. Thank you so much, Varun, for sharing your valuable research with us. We truly appreciate your time, effort, and dedication.
Thank you.
Now we are honored to invite our esteemed keynote speaker, Mr. Satish Kumar Naluri, to deliver the keynote address.
Yeah, sure. Just give me a second. Hope everyone can see my screen.
Yes.
Okay. Okay. Good morning, everyone. Good afternoon, good evening. First of all, thank you for the organizing committee for inviting me to speak at the GRM Conference 2026. And it's truly honored to participate as a keynote speaker and share my insights with a distinguished audience, researchers, and academicians and industry professionals. Myself, Satish Naluri. I specialize in especially in intelligent automation and manufacturing systems, working on the life sciences sector side. So over the past couple of years, the manufacturing industries, especially pharmaceutical life sciences, organizations have been undergoing a major technical shift. Traditional operation systems are no longer sufficient to meet the increasing demands for the efficiency and compliance and scalability. Especially in the today's artificial intelligence world, the intelligent automations such as with the Microsoft Power Automate and the UiPath cloud technologies and the smart manufacturing architectures are fundamental to the transforming how MES ecosystems can operate on that. So in this session, I'll discuss how organizations can leverage the intelligent automation and AI integration to modernize the MES operations, like the manufacturing operations and compliances, and reduce the manual dependencies on that, and building a scalable and resilient manufacturing ecosystems for that. So the main content with the manual workflows in the manufacturing industries, the legacy systems and how they operate on the today's
environment. So the manufacturing and healthcare, especially in the life sciences, it has like a highly complex operational environments. In regulated industries such as pharmaceuticals, biotechnologies, or life sciences in the industry, they must follow continuous balance and potential operational efficiency with a strictly regulance compliances and GXP compliances on that. So, however, most of the manufacturing environments still rely heavy on the manual workflows, which are like an uh, manually developed by the users, and they can navigate the workflows from moving from one part of the manufacturing process to the another one, and some of the legacy systems, and there'll be a lot of disconnecting in between the enterprise systems with the ERPs, and some of them are like in still like in the paper-based processor. They'll be tracking all the process in the manufacturing area with the spreadsheets or normal paper-based tracking. So none of them were like, most of them were not using the electronic batch records history and the ADHRs and the device history records. So this is like an creates some major challenges in the life sciences. So first of all, the manual intervention increases the probability of human error. Second, that's siloed enterprise applications, reducing the operational visibility and manufacturing operations. um, like an especially the activities such as like an audit preparation and validation documentation and deviation management consumes most of the operational effort. Additionally, the traditional MES systems or MES platforms were originally designed primarily to support for like a transactional manufacturing environments, rather than this intelligent operational decision thinking and uh, operations. So such as like the manufacturing complexity continues to increase, organizations require the systems that are not only operationally efficient but also intelligent, predictive, and scalable to that. This is where the modern manufacturing becomes like an crucial one. So especially in that manufacturing execution systems, we are like an evolved significantly over the time. The MES platforms focus primarily on the um, regarding manufacturing events, executing like an production workflows, managing batch executions, and tracking them, all the materials and genealogy of this history and everything. It's played like a crucial role in the manufacturing operations. However, in the modern manufacturing sites, they're like an they require more than transactional executions. Today, the MES platforms are evolving into like an intelligent operational ecosystems. More than like an the architecture also increases with the ERP systems and laboratory systems, cloud platforms such as AWS, Azure, IoT devices, some of the analytical platforms and automation technologies on that. So especially this transformation enables like a real-time tracking for the users, which they can track all the manufacturing operationals, and they have like a clear visibility, and you can do the like an automated workflow orchestration, and you can predict the operational insights, and it's a faster decision thinking and making on that. So one of the more important concepts here is like an it integrates with the industry standards, the ISA 95 integration architecture, which helps organizations to standardize the communication between enterprise systems and the manufacturing operations. So it's like the MES systems, and the key message is like the MES is no longer simply a system of record. They're becoming like a system of potential operational intelligence. So the key things like in the intelligent automations, we have to like reduce the human errors and faster approach. That's what we needed. That's one of the biggest driver of the MES automations, the intelligent automation part. So today we are under pressure to improve operational efficiency and reducing the cycle times, how we are processing that in the environments, and increasing like in manufacturing throughput and maintaining like an audit techniques, and data integrity. The manual workflows creates like an bottlenecks across the manufacturing operates. So for example, the manual deviation, right? So escalations are manual batch approvals, manual reporting activities, if you need to do like a data reconciliation, so everything goes through like an takes so much time, and these are all like an repetitive activities which can be automated and saves like an operational times and increase like an efficiency and risk in that operational. So in today's world, like in the intelligent automation is like an automate all these workflows while maintaining that compliance and the traceability. For example, like in most of the companies can automate to the electronic badge tickets for the workflows, and like in COPPA approvals. If they have any exception escalations, they can automate through the through the intelligent manufacturing automation. So order documentation, product notifications, everything like in the KPI reporting, they can be automated everything. So it's like an automation is like a no longer just about like an efficiency. It's kind of it's becoming like a kind of a foundational layer for operational and resilience and regulatory audits on that. So how the Power Automate can be used here is like an it's becoming like a valuable platform in the automation area, especially for the workflow orchestration and within like an manufacturing ecosystems. So one of the major advantage for the Power Automate is like it's a low code architecture, which allows like an organization to rapidly build the automations. Most of the product owners can if they went through proper training, so they can build automations on that. The product owners are operational owners, operation managements, and they can build those basic automating approval notifications and those kind of automations without any extensive like an coding background for them. So like within MES ecosystems, like in Power Automate can be used like an for like an approvals notifications, or escalating an exception management notifications, or doing an workflow automation, enterprise reporting, like kind of a Power BI reporting, and we can integrate with across all the Microsoft platforms. So you can send out to a notification to the Teams or Outlook. We can communicate with the LIMS or any of the ERP tools. So for example, like in the manufacturing deviation, right? So it's occurring in MES can automatically trigger a Teams notification and email and alerts through Outlook for an escalation approvals. Power BI dashboards, it can update those. We can communicate with the Power BI and integration with the ERP tools, like in connecting to the SAP or like an EDP systems, or any of the quality systems on that. This process can create like a faster operational response times and improves like in cross-functional collaborations. And one of the major benefit with intelligent automation is like an operational agility. So companies or organizations can modernize their business process without replacing the existing MES platform. So this significantly reduces the transformation and the complexity and implementation risk. So the low-code automation enables like in manufacturing organizations to accelerate digital transformation while maintaining like an enterprise stability on that. And also the next part, like in how we can use the UI path to bridge the legacy gap along with the Power Automate. So UiPath is like in one of the leading enterprise RPF platforms that is used in the across manufacturing industries. So many manufacturing organizations are operate within hybrid technology environments, including like in legacy MES systems, ERP applications, and laboratory systems. And some of them have like in custom manufacturing tools or spreadsheet data-driven process. So replacing all these systems simultaneously is often unrealistic, and it's cumbersome to update those. So this is where RPA becomes extremely valuable and useful to automate here. The UI path can automate repetitive rule based tasks across all the disconnected systems. Example including MES to ERP synchronization or automated data extraction or compliance document generation, or if you want to connect to the LIMS integration workflows or batch record processing and all those things. Especially this RPA act as an practical modernization bridge. It allows organization to improve operational efficiency and also achieve an efficiency, gradually migrating to the cloud native systems tomorrow on that. So now we can talk about how we can integrate this into the MES systems. So transformating aspects, including with artificial intelligence on that. So traditional MES systems primarily their goal is record and manage and operational activities. So the AI enabled ecosystem is it goes significantly further. They enable systems to predict operational risk and detect anomalies and analyze the trends and recommend actions, support the intelligent decision making. This transition moves the manufacturing operations from reactive models towards the predictive operational intelligence on that. So for example, the machine learning models can analyze manufacturing trends and identify abnormal batch behavior before failure occurs. Predictive maintenance algorithms can detect an equipment performance degradation and before going to the downtime impacts the production. So all this AI driven analytics can help identify the root causes of recurring manufacturing deviations. Conversational AI assistants can help operators to retrieve approval information more efficiently. So especially the generative AI technologies may eventually support the SOP assist, the standard operational procedure assistance, and providing an operational knowledge, how they can implement what would be the new steps that they need to interact with the MS environment, those kind of knowledge retrievals, intelligent reporting, and manufacturing guidance throughout the system. So however, the AI adoption in regulated environments, it's needs to be it's not needs to be, it must always be carefully configured on that. So we need to be make sure everything was documented properly and followed with the careful extractions according to those GXPs and industry standards on that. So most of the organizations, they must balance the innovation with validation instead of blindly testing on that AI. So data integrity or regulatory expectations and all that. So the important message it's an AI transforms an MES into a reactive operational systems, into a predictive manufacturing, instead of looking at the data and processing to that, which can be predictive analysis and all that. So also the cloud computing and smart technologies, right? So you can especially the IoT technologies are also reshaping the manufacturing ecosystems. Modern manufacturing organizations mostly they're requiring real-time operational visibility and enterprise-wide connectivity, scalable analytics and platforms with a centralized manufacturing intelligence. Most of the cloud-enabled MES architectures support these capabilities, such as Microsoft Azure. They provide an organizations with a scalable infrastructure, data integration services, and analytics capabilities, AI services, and secure the enterprise activity and all that. So the IoT devices further enhance the manufacturing visibility by enabling real-time monitoring for the equipment performance and environmental conditions, and production metrics and like process parameters. Combined together with the cloud, AI, and the automation and IoT, they can create like a foundation for smart manufacturing ecosystems, and the organizations can move towards the data-driven operational decision making and at an enterprise scale, especially for coming to the compliances and cybersecurity for regulatory manufacturing environments. The innovation must always align with the compliances and cybersecurity requirements. This is one of the most important consideration when implementing AI and intelligent automation in the manufacturing areas. So most of the organizations must ensure data integrity and electronic batch records, the audit traceability, and securing like in all the access controls, system validation, and regulatory alignment for that. So for example, like in a pharmaceutical manufacturing environment, right? So we have to follow that CFR Part 11 requirements, which govern the electronic records and electronic signatures before approving any manufacturing workflow moving from one step to another step. So the AI-enabled or automated system must maintain the traceability, and we should control those workflows and change management and validation documents. Everything has to be documented on that. So and cybersecurity also becomes increasingly critical for the manufacturing systems. These are like become more connected on that. So the organizations must implement the secure cloud architectures, identify access management, network related segmentation, and continuous monitoring on that. So the innovation without governance creates operational risk, and successful digital transformation requires like an balanced agility and with compliances and security on that. So the future of like yeah, so as we look towards the future, the manufacturing ecosystems will continue evolving rapidly. We are entering an era of hyper automation and intelligent manufacturing. Future manufacturing environment will increasingly combine AI, automation, and cloud computing, real-time analytics, and IoT and digital twins on that. So especially the AI copilots may eventually assist operators with the manufacturing guidance and root cause analysis and compliance support and retrieving and operational recommendations and the SOP documents, which will save like a lot of time for the end users. And the digital twins may enable like an organizations to simulate manufacturing environment and optimize like in production strategies before operational deployment on that. The future MES platforms will continuously learn from like an operational data and provide predictive intelligence in real time. However, that human expertise will remain essential for that. The future is not about replacing people. It's about like an augmenting human decision making, working with the intelligent systems. The companies that successfully integrate AI and automation and enterprise manufacturing modernization will lead to the next generation of resilient and scalable manufacturing ecosystems on that. The key takeaways are like to summarize like in today's discussion, the manufacturing systems are evolving rapidly. Organizations are moving towards the intelligent and connected predictive manufacturing ecosystems. Especially these automation platforms such as Power Automate or UiPath will help the organizations to improve operational efficiency and compliance related, scalability related ones. It's kind of a cross-system integration. The artificial intelligence enables manufacturing operations to move from reactive execution to like an predictive operational intelligence. It can be predicted based on the analytics and navigate the users to like and what needs to be done on the next step. Especially the cloud technologies and industrial IoT further increases like an accelerate into that enterprise manufacturing transformation. So the future of manufacturing will be intelligent, connected, scalable, and continuously learning organizations that embrace intelligent automation and AI-driven MES moderation today will be better positioned for future operational decisions and innovations on that. Yeah, thank you very much for your time and attention. I truly appreciate the opportunity to share the insights with you today. Yeah, I'm open for any questions if you guys have.
Yes, so thank you, Mr. Satish. So our award selection committee member, Mr. Manohar, is available. So Mr. Manohar, please ask some questions to Mr. Satish.
Hello. I just wanted to understand the impact of agentic AI on robotic process automation. I saw that you mentioned about you can live with or you can integrate with AI. I was wondering from the beginning that the UiPath or Blue Prism or any other automation technology will be highly impacted with agentic AI. But I was fascinated to listen from you that they can co-live with agentic AI. So that will be an interesting facet to understand.
Yeah. So in the current era, right? So for the manufacturing environment, especially in the regulated products, so AI can be usable, but it's like we can't fully depend on that agentic AI on that. So it has to be correlated with the regulated automations in order to integrate with the manufacturing workflows. So that's where like these UiPath or Power Automates are like you can communicate like integrate with the agentic AI and you use it for like a predictive analysis, and the UiPath or regular automation techniques can be used for like an workflow automation, but the agentic AI which was integrated with the Power Automate or UiPath can be used as like an predictive analysis based on the provided data for that. So
Okay. So you are saying it could be used on the different layers, like it could be on the workflow layer and also a different layer. Okay.
yeah, so because if we provided like a direct access, they're integrated with the direct AI, right? So it's like it's complicated with the regulatory products. So and it's getting an approval from like those GX compliances and everything. It's really difficult, and it needs to be thoroughly validated for this product. So yeah, that's why like it has to go through the workflow, and it can helpful for us like in predicting the analysis that would be also it's can't like fully enable that process on that.
Makes sense. That's an interesting viewpoint. I was under the impression that the Power Automation or any other robotic process automation platform could be easily replaced with agentic AI, but that's a deep insight. Thank you.
Yeah, so those for like in regulated environment, right? So apart from the life sciences, I think those Power Automate or UiPath can be replaced with the agentic AI. We have like a lot of alternatives for that. So but within these ones, it's like an rest of these recent tools that came into the picture through the agentic AI. They can't able to build the workflows. They can't be able to integrate with the these MES systems. So that's where these two tools were like an useful for that. So which can be like an integrated with the AI and integrated with the MES environments in both systems.
Yeah, I saw the same in banking and insurance sector. Most of the automation is being replaced with agentic AI.
Yeah.
Okay, if anyone has any other question for Mr. Satish, please feel free to go ahead. Okay, thank you so much, everyone. Thank you so much, Mr. Satish Kumar Naluri, for sharing your insights with us. Your keynote address was excellent and inspiring. We truly appreciate your presence and valuable contribution.
Yeah, thank you for the opportunity. Thanks you. Thanks everyone.
With this, we come to the end of session 3. I would like to express my sincere thanks to all the presenters, participants, and our session chair, Satyam Nikra, for making this session informative, interactive, and engaging.
So,
Thank you,
Mr.
everyone.
Yes, our session chair, Mr. Satyam Nikra, please conclude this session. Okay.
Yeah, sure. Yeah, so thank you everyone for presenting your research as well as the keynote speaker notes. The information is really insightful and valuable. And yeah, wish you everyone good luck. Thank you.
Okay, that's it for this session and for day 1 of our conference. We hope you enjoyed today's session and found them insightful and enriching. We look forward to welcoming you again on day 2 and to your continued participation. Thank you all for your valuable presence and contribution. Thank you. Thank you everyone for your participation.
Thank you. Bye-bye.
Thank you. Bye.
You.
Thank you and goodbye.
Thank you.
Thank you.
Yeah. So, Mr. Norman, do you want to say something? And hello.
No, just say thank you for everything. The all the conference were excellent with new insightful ideas.
Thank you everyone for your valuable time. Now we are going to end this session.